Good morning, everybody. I thought I was going to be the only one that's going to be 15 minutes early to check their audio and video.
Nope, not just you.
Good morning, Jason. How you doing?
Hi, Jason. Hi, Carlos.
Good morning, David. How are you?
Good. Glad everybody can make it.
Yeah. So, do we get moderator controls? Do we get to mute people if we need to?
I'm a moderator. Miss Sarah's online.
And I'm going to check that chat's working this morning.
Yeah, I can't get into chat, so somebody else will have. I've never been able to get into chat this entire conference.
Chat beta integration is working. That looks good.
Okay, I've tried the independent. Okay, let me try it through this thing. Oh, okay, I can get it through. Okay, I can get it that way. Yeah, I wasn't able to get it through this separate matrix thing.
Mm-hmm.
Yeah, I have a separate matrix client connected.
I did. Okay, well, that's good.
Good morning, Jose. Who else is on our list? Oh, Joseph is here. Good morning, Joseph. Joseph, I see that you look like you're listen only. Just making sure that that's your intent for your current connection.
Yeah, it's really annoying that you can't change your audio. You've connected. What is Sicker plonking for?
I don't know what Seger wants.
I want nothing. I just wanted to check that chat works.
It works. Pong. Ping.
Well, it showed up like within a few seconds, and not more than a minute. So that's okay.
Yeah. We're the golden age of the internet.
Like you're not on a dial-up connection?
You mean me?
Anyway, I'm joking about the golden age of internet, where we were talking about baud rates about a week ago in our internal chat.
Yeah.
I think there has to be something to be said about like Parkinson's law for the internet, which is like given any available bandwidth, an application will basically scale to consume all the bandwidth and provide poor performance regardless of how much bandwidth you have.
All the bandwidth, all the memory, all the CPU.
It's Parkinson's law, but applied to like application bandwidth consumption, right?
Yep.
So if you have lots of it, then application authors are sloppy with their data in exchange formats, and so. Good morning, Patrick. How are you?
Good morning. Doing fine. Just making sure my camera works for my presentation in an hour. I'll
Excellent.
be in the background for the steering committee.
Okay, great. Yeah, thanks. I mean, you almost do lots of presentations this year for the Tools Track. We appreciate all your great work and taking the time to make all these presentations. Maybe you
Thank you.
Maybe you didn't expect that all of them would be accepted.
Well, my manager encouraged me to, oh, you did this. Why don't you do a presentation? Oh, you did that. Why don't you do a presentation? Lena is my manager. So I think maybe
Elena.
we were a little thin on people submitting at the particular time she was encouraging.
Yeah, I mean, it's hard. COVID has
Oh,
been hard on people and work and availability and that work-life balance. And sometimes people feel less motivated these past couple of years to do a presentation on anything, for sure. Thanks, Patrick.
Yeah.
Speaking of which, Patrick, given that I've got you here and we're randomly ahead of time, I have several interesting graphs of what happens to malloc workloads as you raise and lower the bar of those 3 parameters you talked about yesterday in your talk. Because what I often do is when we have a customer that has a malloc issue, and it's usually around performance or size, we get them to run the high-speed tracer. We get a dump of the trace. We rerun the trace through the workload simulator, which basically lets you redo all of the allocations in sequence. We store them in a known global order across threads in an ordering, and we recreate the threads as well in the workload simulator. And then we have a look at what like tuning a couple of those parameters would do for the customer's workload. I really
so you don't have to rerun the workload then.
Correct. So,
Right.
and we presented this a couple of years ago, and we still have it out of tree. But the idea is that with the malloc deprecation right now, we could then potentially move to integrate the high-speed tracer. It generates a ton of data because it's basically pure API trace for you to rerun it in the simulator. And it's funny because, like, just orthogonal aside, on the RISC-V talk, they're talking about whole workload tracing for RISC-V, RISC-V in QEMU, and I'm like, that's bonkers. I can't imagine how much data that's going to generate in order for them to look at the analysis of that. But even just a finite small amount of malloc API trace is a massive amount of data. But then you can play with the parameters that you talked about. You can kind of raise and lower the bars and see how things go. I think the interesting questions for us today are going to be around someone looking at that and seeing how those bars matter, if they actually matter in practice to real workloads. And I'm super curious if you're going to pick one of those bars and look at a real workload from a customer and then say, can you improve it or not? I'm curious to know if the bars improve things. My gut feeling is that functionally the bars change the trade-off that we have, but that there may be other things we can do that improve performance more significantly than looking at setting that bar at a new value. But I agree with you that setting the bars at new values is low-hanging fruit in terms of, if you look at modern workloads, are the bars set at the right levels, yes or no?
Right, because things have changed a lot in the last 15 years.
Sure, yeah, absolutely. But they've
not entirely in one direction. We've
correct.
gone to massively increasing the number of threads, which puts more memory pressure, even though we have lots more memory. I heard you somebody saying something about applications expand to fill all available memory.
Parkinson's law, yeah.
Yeah.
So I know of a customer who used to have an application that was like single threaded, and it was great. And then they came back and they're like, our application's consuming a ton of memory. And I'm like, well, what have you guys done? And they're like, oh, well, we're running 1,500 threads now. And I was just like, well, because I mean, it's an instantiated thread pool, and so they're expecting the threads are basically zero cost, and that as you're just scaling out the workload with a thread pool. But thread pools aren't necessarily what a heap-based allocator was best designed to handle. So I think there's maybe some thought around, in a modern producer-consumer or a modern thread pool, what does that mean for glibc's malloc? What direction does that? Like, is there even anything we can do to go in that direction? Now, there is, I still think there's value in still having in the ecosystem a heap-based allocator, and there's still value in the ecosystem having page-based allocators, because they do drastically different things on drastically different workloads. So I'm at a global level, I'm not overall convinced of replacing everything with page-based allocators as being the best solution to all customer workloads.
Right. I think what I got out of the simple experiment I did was the desire to, on a system-wide basis, it's not as important to immediately return memory. But after a small amount of time in human terms, or even though it's large in computer terms, it's time to just wake up and see, am I holding on to a bunch of memory I don't need to? That kind of idea.
That is a great idea, and I see it most often in customers whose applications are batch processing workloads in evening times on, basically optimizing compute resources. So you get to the evening, you've got free compute resources, you batch process. So what happens is that application that is basically long-running batch processing, it scales up its memory during the evenings, and then it scales down its usage right away. But a page-based allocator may not necessarily free everything back down. And so you really do have this temporal waves of work being done. And in between them, if you had a delta T decay, you would have corrected for the amount of memory you had, right? Like if you're talking fundamentally like a PID controller, like if you stick a PID controller in front of this thing, the proportional thing doesn't matter, the integral thing matters, right? And so it's the derivative matters, because really what you want to do here is there has to be a delta T component to how much you're consuming, how much memory do you leave left over. And I think JMalloc does it well with an extra thread, and they say, okay, we're only going to keep about 5% of excess stuff around once we get back to our time decay. And I think we don't do that in glibc, and we could. And the answer we often say to users is, well, run it yourself, right? Do a time decay and call malloc trim every once in a while. As malloc trim will walk the pages and free all the pages. But that's all the pages. You may not need to free all the pages. You may just want to free from the back forward a certain percentage and then stop. And so I think with Florian's work to merge, in my opinion, libp thread into libc, we've now got threads, right? We've accepted that threads are a thing that it's always going to be available for people to use in workloads. So in the background, we have this option of, do we create a background thread for malloc like JMalloc does it, and have that background thread do some kind of accounting, or have the accounting process get rolled into the cost of the allocations? And then in the background, you're freeing some of that memory back when time goes by and you notice there's too much pressure.
Right. I was thinking more in terms of if you've got many threads where the application is structured to have one thread per user interaction in a client server model. And they're very active for while they're looking up things in the database or whatever. And then they go into a pause state while they send a message to the client, who just kind of won't come back for how many ever seconds before the say it's somebody on eBay deciding whether to bid on an auction or something. And so they'll sit there for 20 seconds. During that 20 seconds, you can get back the memory, as a 1 second or 2 second delay.
Mm-hmm.
That was just the model I was thinking of, that kind of application.
It's the
There are
same.
many
It's
others.
the same model, right? Because it's a
Yes.
delta T decay of you're watching for that memory pressure. The other issue I think I have is that with thread pool models, the thread's workload changes drastically every time the thread gets returned to the pool and comes back again. And in a page-based allocator, it's almost model agnostic, because the pages don't care the temporal order of allocations as they happened. But in a thread pool, when you use a heap-based allocator, the previous accrued state of, what went on in the past is basically encoded in that heap as you made all the heap transactions.
Mm-hmm.
And so it's like when that thread gets reassigned to a different possibly workload out of the thread pool, you really don't want to keep any of that stuff around. You're uninterested in keeping all that excess around because you don't even know if you need it, right? So now, and I think that still can be solved with a temporal delay, because if the threads go back to the pool and they sit in the pool for a while, then we can use a thread that's watching a temporal decay time go by. Basically, it can start cleaning up any of the memory used by those threads in the thread pool. So basically, the thread pool's memory utilization shrinks as the thread pool is less used, and it grows as the thread pool is more used. And that's not something that we're doing well today, given the heap-based
Right. And we probably want some tunable thresholds to experiment with at first, because you don't want a big lag when you first start up a new question. It's helpful to have a little bit of memory that you don't have to ask the operating system for to get started in that first beginning of a query.
Sure. I don't know how much engineering
Yeah.
background you have, but in a PID control, that's anti-windup, right? So in
Yeah.
PID, you definitely have what's called windup lag, and so you most often deploy anti-windup on a PID controller because you are saying, when I start off this thing, I don't want to start at the bottom and have to ramp all the way up to my set state for how much memory I think I might need for my workload. So
Yeah.
starting off with some memory in the allocation is fine, and I think that you just tune that by how much you're willing to free versus like total percentage used of memory you have.
Right.
And this
I was
gets
actually just thinking of my own experience in Windows. The first time I invoke Firefox, Libre, whatever, there's this big lag. And that's annoying.
Mhm.
That's the wind-up lag you're talking about, I'm sure. The name is self-explanatory.
Yeah, in those cases it might be page cache-ish, right? So like you're having to bring in an entire application in. Yeah. I
Well,
don't know
it's
how.
almost 9 o'clock, so
Yeah.
Don't want to distract you from your steering committee work. It's
I feel like this is exactly like we would be at
Oh.
at live tools Cauldron.
All right. Of course, what
Patrick.
got my interest in Malloc going in the first place was 2 or 3 years ago, we did an internal study for spec CPU results because we had new hardware and we wanted the best possible numbers. And glibc Malloc on a couple of the benchmarks was substantially worse than JE Malloc. And I was going, well, is there a reason for that? Is there some tunable that could fix that? And it was a background activity for me. I haven't been able to really focus on it until recently. But yes, we can fix that. I have not yet done the experiments, but I'm sure if we just change a couple of tunables, we can use glibc Malloc and match JE Malloc for those particular benchmarks. And then we won't have to submit results with JE Malloc to spec CPU. We can just set some tunables, which is an allowed option for spec CPU rules. And that's without even changing any of the current implementation of glibc Malloc. I'll put some things on libc alpha for thoughts on how to changing some of the internal pound defines that I've been considering, and mostly just thinking about doing it all and then submitting it. Now I'm thinking maybe I should get some discussion going before I put in a lot of work.
Thank you, Patrick. I appreciate that.
Okay, I think it's 10 a.m. on the East Coast, 7 a.m. on West Coast of the US, and I won't try to translate for the rest of the time zones around the world, but let's start off and welcome everybody to the third day of the GNU Tools Track at the Linux Plumbers Conference 2021. Go through a little bit of the housekeeping, just to thank all of our sponsors again this year for the Linux Plumbers Conference, the diamond sponsor of Facebook. IBM is platinum sponsor, gold sponsors of ARM and Microsoft, silver sponsors of Amazon AWS, Netflix, and Red Hat. And speaker gifts were provided by Collabora, and t-shirts will be provided by VMware. That if people respond, the first I think is 100 or so at the end of the conference. And of course, the conference services have been provided and hosted by the Linux Foundation. We want to thank the Linux Foundation and the great effort by all of the members of the Planning and Steering Committee, including Elena, who's on this call as well, James Bottomley, Kate Stewart, Chris Bronner, Guy Linari, Steve Rosette, Jonathan Corbett, And also wanted to have a special thanks and shout out to Embicosm and Jeremy Bennett and Sarah Cook from Embicosm for helping to lead the great effort in the program committee for the GNU Tools Track itself and helping to provide all the administration. So thank you very much to both Linux Foundation and Embicosm for all of their great support with this effort so that we could have a successful GNU Tools Track this year. So thanks everybody for that. Now, if let's see, how to Sarah can help with switching over to the next presentation. So we'll start out this year with the GNU Toolchain, GNU GCC Steering Committee, and GNU Toolchain Stewards event this year, the Q&A panel. So we have some people both on the call here and the number of, and some people from the steering committees and the stewards lurking, including myself, David Edelson. I'm on the GCC Steering Committee, Carlos O'Donnell from glibc Steward, Jason Merrill, who's in the GCC Steering Committee, Jeff Law in the GCC Steering Committee, and we have at least Joseph Myers, who's on both glibc and GCC, though not listening in for this. So just give people a little bit of background about sort of the status of what's happening, the incredible development activity that we've had this year in all of parts of the GNU toolchain. GCC has had almost 9,000, almost 10,000 commits with 372 different developers contributing to GCC. GDB GNU Tools repository had 4,582 commits by 209 developers. glibc had 1,664 commits by 139 developers. So there's a lot of incredible activity and a lot of great progress in all of these projects. So it's really exciting that we have such a thriving community. That's the basis for the Linux and cloud ecosystem. So it's great that we continue to drive forward with the tool chain that's the basis for Linux distributions and many of these hybrid cloud efforts. And also thank out to the great work by our Google Summer of Code students, at least for GCC. We had Arthur Cohen working on Cargo Tool for Rust, Ankur Sayani for extending the C++ support for static analysis, and Wajang Yang for the static analysis of unreachable functions. So that was great progress in GCC from Google Summer of Code students. And highlights, this is just what I picked out. I mean, Carlos can jump in with other things, but great work that has happened in the past year for glibc with tunables, hardware capabilities, the coalescence of many of these different dependent libraries, including libp threads into libc. Of course, a lot of architecture-specific improvements in GCC, C++20, a lot of great improvements for OpenMP, and of course, optimizations work by many of the incredible developers, especially Richard Biener and for all of the great leadership that he and Joseph Myers have done as and Jakub Jelinek as the release managers for GCC. Of course, GCC Rust and the Rust GCC CodeGen GCC, which hopefully people heard about or can go back and hear about from the Linux Plumbers Conference referee track. We have great presentations on the first day. GNU Tools switching over to a C99 as the basic required language, and of course lots of architecture improvements, and GDB support from Oracle, and Jose for BPF, all that great infrastructure that's been put into the entire GNU tool chain, and lots of UI improvements for GDB. So lots of incredible work this year for the entire tool chain, which we really appreciate all of the developers. And so that's sort of my summary of what's been happening. So now open it up to great questions from the audience. So what people want to hear about for the leadership of the GNU toolchain.
David, I was going to say, if one of the extra things I did want to talk about here, I didn't get a chance to add anything to the slides. My apologies. Is CI/CD for the GNU toolchain. So there is a bunch of CI/CD work that we are trying to do to really bring up and bootstrap an initiative for the GNU toolchain based on patchwork, based on container deployments. DJ Delore, who's on our team here at Red Hat, is working on CI/CD, and for over 5 months, we've been doing hundreds of CI/CD reg tests as glibc patches arrive to the mailing list. And it's interesting because, from a GNU toolchain leadership perspective, I think CI/CD is one of those pieces that we in the toolchain are kind of missing. And when you have CI/CD, it really gives developers that confidence to submit a patch. And for glibc right now, we are running a linter. So you submit your patch and the linter automatically gives you some status of whether the patch applied. And we're going to extend that a little bit. And it automatically runs a 32-bit x86 build, just because it's an architecture that we is not as often tested as, let's say, an x86 64 make check. So for 5 months, we've been doing this for glibc, and it's being functionally driven through patchwork, which is on the side of the mailing list. And so from my perspective, I really think this is high value for the GNU toolchain to look at CI/CD testing, specifically try-bots for patches, in order to assist maintainers and reviewers, largely because reviewers have limited resources in their day, and getting a lot of green successes on a patch that has just gone in, you can immediately see, oh, has it built across all the variants architectures I want? Has it built across a specific configuration I'm interested in? And more than that, we're looking at reviewer-driven CI/CD, where if you're a maintainer of glibc or GNU Tools or GDB or GCC, that you basically can send the list a signed message saying, hey, trybot, I want this additional test to run. And so you respond to a patch saying, trybot, tell me, did this thing run on this configuration? And the trybot, knowing who you are with your GPG clear sign request, will potentially run a build. So I'm really keen as a GNU toolchain developer to see that CI/CD work extend across all of the GNU toolchain. So that's kind of where I see there's a lot of high value across the GNU toolchain in the coming year for CI/CD, for accelerating the capacity that reviewers have. I know for people that have been to the glibc BOF, I always talk about this. I'd love to be able to review 100 patches in a day. And the previous answers at the last 2 cauldrons have been drugs and no sleep. And I said, no, we have to make it possible, not with drugs and with some sleep, that I can review 100 patches in a day. And I think CI/CD is one of those things where there's the potential for us to really look at a lot of patches in one day. So that's what I wanted to say today to talk about CI/CD in the GNU toolchain as a whole. We've started with glibc because it's something useful. We've actually just turned on patchwork on sourceware for GCC patches. We already have GNU Tools in there, and we already have GDB in there. And I know Jonathan Wakely has been tagging some patches as reviewed because having a list of patches is really useful. And also Git PW, which is the patchwork command line client, lets me automatically just say, Git PW, give me that series, applies it to my Git tree, and then I can immediately start testing it. So that's it for me.
So Carlos, you and I need to get together. I have moved my GCC tester into a Docker framework. And it seems to me that if you've got patchwork sitting on the GCC lists, all we need to do is wire these 2 things together at this point.
That's what we did with DJ. So what we do with the trybots is the trybots are effectively, we're using Podman, but Podman or Docker doesn't matter.
Yeah, same in the end.
Basically what happens is patchwork gives you an event queue. We then have a curator that listens to the event queue and curates those messages, and then you've got individual runners. And so the intent would be that IHVs, ISVs that are interested in putting together a trybot, you basically run your test, and then you contribute the upstream success warn or fail to the checklist. So when you as a reviewer are looking at a patch and you're looking at the results for the data, you get the aggregate success warns or fails of all the interested parties that were looking at those patches arriving on the mailing list with their trybots running. And a trybot is effectively just a runner with a local... It's just a local runner with an AMQ that basically runs in the container. DJ can talk more about that. There's a little bit of hardening you have to do because the container has to run with the network off, because when you run a trybot that takes random patches from the mailing list and runs it, you want to make sure that it doesn't it isn't capable of carrying out arbitrary computation whose results can be returned to the user in a way that's meaningful on the mailing list, so that they, mine bitcoins using our mailing list. But I'm sure we'd all catch on pretty fast if that happened. So
Yeah.
and
So
Joseph,
anyway, yeah, you DJ and I should get together on this topic.
yeah,
and
Joseph, your
see how we
comments,
wire these
yes,
things together.
a build many glibcs bot running after commits. But doing it as a try bot for all posted patches would need a lot of compute resources. Joseph, so to answer Joseph's question, this is really the concept of reviewer-driven CI/CD, where if you see a patch land on the list and you're like, that patch touches a public header, so you say @build trybot build many glibcs. Trybot sees that as a request and drops an event in the queue that says Carlos has requested a build many glibcs for this patch, for this message ID patch, basically. And so that would, for example, be a way in which you could kick off resource-intensive CI/CD steps. So you can run a build many glibc. Build many glibc, for those of you who don't know, in the GNU toolchain, within glibc, we have a script that basically builds every ABI variant, something like 72, 75 ABI variants, all the cross compilers, all the host libraries, all the glibcs, all the bin utils, everything gets built. It all gets run down to the bottom, and it all gets compared under like a regression test for glibc, basically. And so what we're looking for is build fails across one of the architectures or in other places. So it is hugely compute intensive. And yeah, Florian, DJ, and I often we spec out machines to see how fast a machine can run build many glibcs, and we have this ongoing list of like what's the fastest box today that we can get 72 cross target ABI builds done as fast as possible to make sure that things still build. You need a lot of CPUs. So
So for GCC, what would be the criteria of a pass and a fail of the CI/CD?
you tell me.
Well, it's difficult. I can't. Well, it builds maybe.
Sure.
So right now, Richie, the way I would approach that would be, does the test compare script in our contrib directory for whatever target we choose to run it on give you a regression failure? That is the definition right now in a tester.
Yeah. So you actually need to build twice.
Yep.
Yeah.
Well, actually, you save the artifacts in the current mode. So the last build, you always save the last successful build, and you can compare against that for a regression.
So this takes almost 10 hours per target.
No, not even close.
Well, it does.
No, because I'm running it all the time. It does not take 10 hours per target. An embedded target takes about 1 hour.
Then you run the test suite in cross-compile mode. It doesn't do like 90% of the test then.
So for a cross target takes about an hour. For a native x86 takes 2 to 3 on the hardware that I've got.
For 2 builds?
No, you do 1 build and compare against the last successful build.
Okay.
I mean, there is no doubt that some of these things are computationally expensive, and they will require some compute resources, and that is going to be an ongoing conversation. But it's
an ongoing conversation, and there are organizations that can help. So the last 2 or 3 years, Amazon has given us credits in AWS to run tests. I just apply for them. They give them to me, and okay, I'll ship the stuff to Amazon. It's like $5,000 a year. It's not a huge amount of money, but it's enough you can run a small little farm in there.
But
so there are resources out there.
We are supposed to save the planet, right?
Yeah, this is not conducive to that.
And we are saving the planet by making the best FOSS tool chain that there is, and using that FOSS tool chain to build products that will save the planet. But we need to build a robust, reliable tool chain so that other people can build things and have them not fail and have them save the planet. So we're just helping people save the planet. Yeah, I mean, so CI/CD, I mean, glibc is a lot easier to build. And I'm looking at GCC patches now because it's one of these things where, like, if we can scale to GCC patches in terms of some compute resources in putting that together, then it works. Now, the nice thing about Patchwork is it's a centralized repository with success, warn, fails for recording the check results. We can distribute the checkers in as many runners as we want and as many different hosts and setups as we want. But I don't want to hog all the time. I just wanted to make a comment that I see, we've made forward progress on full CI/CD for the GNU toolchain, and I want to keep that moving forward, and I will for glibc. I'm going to talk to the rest of the GNU toolchain components to say, how can we help? Is there anything we can do? Is there anything of value? Is there anything that fits into your workflow? And the integrative, patch submission trybots have I think have a lot of value, because right away when something fails, I can say as a reviewer, I'm not going to review that, and I'll send the person a message and I'll say, this thing is broke, it's not working on this thing, and then they go, oh my god, I didn't even know that would work that way. And so it yields the highest value for me as a reviewer. Neil Gumpa asks, is there something like a build bot planned? This is one of these hemming and hawing things about post commit checking versus pre-commit, and I think the patch trybots on the mailing list, in my opinion, have immense value. Yes, there is value to check more things once you do a commit, but once you do the commit, you're already interrupting other people's workflows, and so I feel like we have to bite the bullet in building something that is operationally secure and is capable of testing patches as they arrive on the mailing list.
So I just looked at the patchwork, and I see there are entries like patches sent from me, but they are a bit in between committed into the repository. So patchwork doesn't cross-check with the repository for patches that have been pushed.
Not by default, but we have patchwork bots that do that for glibc, and it's basically a script that goes in and does the cross-checking and marks things as committed, because you can mark the entries as committed when you're done. So you can do a little more integration, and the reason the integration is left up to us is because we need to decide what workflow works best for each of the communities. Right, Sudesh says right now he's the bot that runs this for glibc. Yeah, so he's totally the bot that runs it for glibc. Yeah, so that's where we are with the commit, because each community could have a slightly different process that happens when something gets committed. So Jakob raised a question about patches slightly changing before commit. I'm going to call this out as a bad habit, right? Changing your patch before commit is simply a bad habit. What you post is what you should commit. Now, that may not be what you're doing today, and if you don't do that, I hope you feel a little bit of shame and you say, yeah, it's a bad habit, but I like biting my nails, and I gotta get out of the habit, but it's hard not to change things before I commit it, And we found very quickly that for transparency, for honesty, for being clear with people submitting their patches, what you push should be what they gave you, and that's something that we really want to stick to.
Well, I think you tie that into the longer term. We tie that into a patchwork flow. A reviewer has run through patchwork. The reviewer has looked at the code. He clicks the button and says, "That's good." And so, what was in patchwork goes into the tree. And if you have to, somebody needs to make an adjustment, they make an adjustment, and it goes through that process again.
Yeah, and I often just ask people, I say, send me a new V10, and I'll act that one because it'll have all the final changes just to double check. One of the interesting benefits of patchwork is in glibc we're trying to track reviewed by, so track reviews, right? Give credit where credit is due when people are reviewing things, and Git lets you aggregate who was the reviewers, who was doing a good job, who should I be thanking, who should I be encouraging to do more review, and that kind of thing, which is part of community building. It's part of encouraging the volunteers to become reviewers, because we'll all be honest, review is a thankless job. But when you get your I admit that there is some there's some good feeling when you see your name in the reviewed by line, and you feel thanked for the fact that you did a ton of reviews. And so the reviewed by lines actually get aggregated by Patchwork for you if you're using the Patchwork client to pull down the M boxes and git AM apply them. And so you don't have to even bother. Like if you got 5 reviews and you get AM out of a git PW pull for the Patchwork series, Patchwork will watch that thread, know that a bunch of people gave you those reviews, it will aggregate them for you, put them into the commit message, and then it automatically just gets pulled into the thing you applied as reviews. So then the reviewers get thanked, and the reviewers, and you just give that little bit of kudos to those reviewers to say, hey, I've recorded your review. Thank you very much for the work that you did. And Jakob is posting about the, patch changes, nits fixed, and things like that. So Jakob says a repost and another review is unnecessary. Yeah, it is unnecessary, but it makes.
Well, I think for that case, we could have a fast path through the system. If I've said fix this comment, all you want to do is verify things build, and you only need to pick one target to verify they didn't forget to close the comment or something of that nature. So there should be, we should be able to build in a fast path that just says build a cheap, easy target. It builds, okay, so that they fix the nits and let's move on.
Yeah, I agree. Yeah, and I think if you're the more automation you do, the more you want crisp boundaries around. This is the thing that I okayed to go in, and it went in exactly like I said it would go in. And so sometimes it just is a matter of the reviewer cleans up their patch and then just posts a patch to the mailing list one last time with the words, with square brackets committed, and said this is the thing that's going to go in final. And that actually makes it easier from the automation perspective because you can close every version below that one is superseded, and that one patch from a patch tracking perspective gets marked as committed automatically by a Patchwork bot that knows that committed means that thing hit the mailing list. So. Neil says, I barely like appending the act by reviewed by to the patches before adding them. Yeah, I agree. It is just a bad habit of changing anything. But I mean, I'm gonna be clear. We justify the bad habit by saying it makes our workflow require one less step, one less post. But man, when I'm at V12 or V13, I'm fine. I'll make a slight change. I'll repost it. That gets final act, and then that final thing goes into the series, and I know exactly what I submitted is exactly what went in, and that's like in full transparency. I think we've had problems in the past in our communities where, sometimes maintainers, and I'm not calling anybody out, but there have been bad habits where maintainers rewrite volunteers posted patches, and that's a really bad habit. So, yeah, it's a really bad habit, Jeff.
I know.
So, anyway, I think we're not here to talk about bad habits. We're here to talk about the positive, good habits that the crisper we are about our transition boundaries for patches and getting them in, the better CI/CD is going to work for us. And yeah, CI/CD is going to take resources, and I think you will find that it bears fruit for targeted testing, for patches arriving, for linting, for things. It helps the early developers posting patches and people who might be new to the community posting patches as well. Yeah, we've talked a lot about CI/CD. Does anybody have any other questions they want to ask? Non CI/CD.
The floor is wide open.
Yeah, we can have a separate BOF if we.
Yeah, so there's a question here from the community about Neil again about email-based workflows tracking feedback. Yeah, and so I'm going to raise this as I have had reviewers that have submitted patches to glibc and GCC. We have slightly different workflows in the way we ack things, right? And so in GCC, it's like you traditionally go like ack or okay or something like. What does that really mean? Like we lack crisp boundaries around that review. That patch is reviewed. It was good. I'm okay with it. And I think the Linux kernel ahead of us found that these these loose boundaries around whether or not a review was okay is problematic. And I completely accept the blame in glibc for a consensus-based process where the review is not crisp. I would like to improve in glibc what it means to get a reviewed by tag, and if there's at least one reviewed by tag from a developer, you've now got some kind of consensus that that thing's okay, and then move on. I would like to see the GNU toolchain adopt something like a reviewed by tag, because a reviewed by tag makes it incredibly crisp that the reviewer has said, I reviewed it, this looks good, it's good for inclusion. And GCC, I think, has the concept of, you've got a global maintainer. So if a global maintainer gives you a reviewed by line, that's gold, right? You're basically done. And maybe the concept has to come to glibc as well, that even if we've got consensus, we have this notion that subsystem maintainers have consensus unless someone steps in and says, no, that's a really bad idea for some reason, in which point we discussed that something needs to change. So it may be that in glibc we adopt some concept like GCC of a subsystem, more strongly the concept of the subsystem maintainer, where if you get a reviewed by from the subsystem maintainer, that's good to go, right? Like that thing can go into that subsystem. But I do think we need crisper lines on patch review and patch acceptance. Now, do you think there's a problem in GCC, Jason or Jeff or David?
I don't see a problem with a global maintainer giving the app. Where I see one of the issues that I have seen is sometimes it's not clear who can give that. And so whoever submitted the patch is like, all right, was that good to go or not? Because I don't know. They may not be as familiar with our processes as we are, obviously. Mm-hmm. So that step of how do we go from there's a patch, somebody has reviewed it, even if they aren't a global reviewer, even if they aren't necessarily have a reviewer status. When is it good to go? And so sometimes people don't know if they are really good to go at that point. But that's also where I think if we tie this into the patchwork system, there'll be people who are authorized to say this is final, it's good, and then the patchwork system actually does the commit rather than the maintainer or the end developer. I want to get us in terms of us doing the as much out of this process as we can.
Sure, yeah, but like that still, I mean, like globally, that still requires someone who has the capacity to push the merge button, basically.
Yes, it does.
What we're talking about. So Neil's comment on the discussion here is, if there's a person responsible, then that responsible person has to both identify themselves and say this thing is good to go. No matter what process we accept that to happen under, someone has effectively what's called decision rights, right? That person has decision rights to push the PR or MR merge button. And in our case, right now, it's whomever has GCC or glibc group access on sourceware for Git.
Mm-hmm. And what I'm saying is that gets encoded in. Essentially, you'll be authorized in the patchwork instance, right? There's an authors that you have to authorize. You have to authenticate yourself, correct?
Mm-hmm.
So there'll be a set of people in patchwork that are marked as these people can act a patch. And so so once a patch is reviewed, so let's say that somebody else reviews it, even if they are not a maintainer. Somebody who's authorized to send a patch into the tree pushes the button. So he reviewed it. I trust him. Good to go.
Mm-hmm. Yeah, sure. Yeah, I mean that's a process we can. But like, who would be those people in brass tacks right now? That's global reviewers. And so
you start with global reviewers and subsystem reviewers.
Yeah, but the thing is, aggregating the reviewed bys, I think, helps the global reviewer, because global reviewer can say, oh, these 3 people have reviewed this patch, and you're collecting the reviewed bys, and the reviewed bys automatically aggregate. If you use Git PW, you can do it by hand if you want, you can do it by email if you want, and then the global reviewer may just say, that's fine. Like whether or not you adopt an automated process where patchwork auto commits it for you, or whether you just do your normal thing where you commit it. I do think Patchwork helps because rather than having to do a whole bunch of dances, and this is something that the kernel people are working on with Lore and the Before tool, you just need to use git pw. You say git pw series apply. You just do a little light testing, and then you commit it. So git pw.
So the only benefit of this is that it will be easier to just say, yeah, whatever, just commit this. That's the only benefit, because everything else we can already do without any hassle.
The only benefit of which specific steps? So firstly, Patchwork brings you a place to hook up all your CI/CD.
Propose here that that you can just look at reviewed by lines, whatever, and then say, yeah, whatever, then it will be okay.
No, I will expand on that and say the benefit is that we have a community of developers that I want to grow. I want new volunteers. I want new people coming to the community. I want new people working with us. I want people from other communities to come and work with us. And those people, will look to our process. Yeah.
I want more reviewers, people who actually review stuff, because we need more of those.
I agree. So my answer to that is that recording reviewed bys is a positive social incentive for reviewers to put their names on the fact that they reviewed something, and to
get it into the repository, you mean? That's
yes.
Yeah, that's correct. Sure.
Yeah, they're like, I mean, these are human problems we're dealing with here in terms of motivating people, engaging people, having them develop and use the tools that we have, following the founding principles that we have for our FOSS toolchain. And yeah, I think reviewed bys help new reviewers put their name on it and say, I reviewed it. And imagine that after like 100, 200 reviews or something, like Jeff's been looking at this review, we're always reviewing the subsystem. Then you say, hey, you've been reviewing every patch in the subsystem. I've got a good record of your reviews, right? I don't have to go back to the mailing list and hunt this down. It's much easier to write automated tooling to look at a record of reviews, and I can say this person has been doing a good job. I've got a track record of reviews there, and then we work through that process. So to answer your question, there is, we can do a lot of things today with the existing tooling we have. I'm looking at how do we improve this for new people? How do we improve this for onboarding, for integration? Yeah.
But Carlos, how do you tell that the person has done a good job without looking at the reviews themselves? If all you look at is a summary and that the stuff gets collected automatically from the reviewed by tags?
So that's a great question, Jose. But I guess ultimately, if you're going to look at someone's work, you can start with the commits. You find all the things that they reviewed, and then you go and you find those reviews as they were done on the list, and then have a look. It's additional metadata that's collected. You're right in that it is only an indicator. You would still have to do an actual review.
Yeah, I actually agree with you that reviews are a very good way to attract people to become more active.
Yeah. I really would love nothing more than to see people say, hey, look, I've been reviewing these patches. I mean, review is kind of a first step sometimes for people transitioning from early small projects to slightly bigger projects. And I consistently encourage members on my team. The nice thing with Patchwork also is I can delegate reviews to members of my team and say, hey, look, here's some patches that I think you are ready to review in terms of your skill set, what you worked on, what subsystems you've looked at, what you've reviewed, and being able to delegate and say, look, here are some things I think you could review. So I will say this, for glibc, we've started every Monday morning, 9 a.m. Eastern, we do community patch queue review, which is walk the queue of patches for the community and say, anybody interested in reviewing this or reviewing that or reviewing this, and we try to get volunteers to review those patches, and we record the delegates, and I take notes and I submit them, and we've been doing that for months now, and I feel like it has borne positive fruit in terms of getting things through the review queue, Where I think where it hasn't helped, it probably hasn't helped get new reviewers, but I think to get new reviewers, I have to add more clarity to how this process works and probably publish some updates for the contribution checklist.
A comment as myself as a potential reviewer, the challenges I see I'm facing are, first, I have my own, job-based deadlines. Some interesting patch comes in that I might be qualified to review, but I may not be able to look at it for several days. And then I'm unsure as to whether it's even worth looking at because maybe somebody else has almost finished reviewing it. I don't have any clarity about other people working on it. And the second part of that is, am I qualified to review it? Take Malloc, for example. I've looked at Malloc quite a bit, but I don't consider myself fully qualified or fully expert on all aspects of Malloc. It's a pretty big code base just within that little subsystem. So I'm not going to be quick to review some other code. I'm going to have to do some study of some corner of Malloc that I had not looked at before.
And Patrick, to answer your question, I think you're fully qualified and completely qualified to look at that code and say, at an architect, like, does this make sense? Like at a high level, does the architecture look okay? Are the details okay? And if you gave a reviewed by to some other person's Malloc patch, that would immediately draw my attention to the fact that I should go look at this. And you should get your reviewed by recorded in that review, so that when Elena asks you what you've been doing, you can look, I reviewed this patch and it was good for this and it's good for these customers and good for this use case, so that you also can have like some justification for your, for our patrons who are supporting the FOSS tool chains.
Yes, that brings up another challenge for FOSS in general. Is there's even a greater distance in FOSS between the developer and the customers than in a corporate closed software. That, I can see something needs to be fixed just because I've been a developer, and so that ought to be fixed. But I may not know, well, I sure don't know a significant part of the user base. It's such a large user base, it's hard to know who might use it.
I think that's okay, Patrick. I think that you are present, and I'm going to go on a limb and say that with your corporate connections and the work that you're doing, you do have contact with customers. You do have engagement with those customers in downstream. So I think, if anything, your presence in these upstream communities brings a little bit of those customers, those stakeholders' priorities upstream to say, hey, I know people who are using this because I get to see them in my day-to-day job and they tie into them. Yes, we will have other users. Yes, we have other people, but we also have other connections with them. I think, for example, that the use cases in GUIX are very interesting to the GNU toolchain. GUIX, with its bootstrap seed and with the reproducible builds that it has, very relevant to me. And there are times when I've interacted with Ludovic Cortez over LD audit issues and how to use LD audit to build fake roots and things like that. So there are other users like GUIX, and I think we are integrating with them. And the way that we do that is by making sure that all of us, GCC, GDB, binutils, and glibc, have some distro contacts, right? So I think it's really important that we speak with the distributions, and then we talk to the distros, and we make sure that we understand how they're using our tools, because our primary users are actually our distros. And then after that, we've got all the users that are using the distros. And so we need that integration point.
I guess I'm just a little spoiled. Several jobs ago, I worked for a startup that had a customer base of fewer than 1,000 and a total employee count of fewer than 500. And I had frequent close contact with any customer complaints. They came quickly all the way back to the developers, which just doesn't happen in large organizations in the same way.
Yeah, honestly, I think our direct integration point there is GUIX Debian, Gentoo, Fedora, RHEL, SUSE, Ubuntu, right? Having that direct integration point with the distros is in my opinion incredibly useful to ask them, how are you deploying this? How are you using it? What flags have you turned on the compilers? What are your default flag settings? What are you building with? What are you testing with? Is it just O2? Is it not? Did you build glibc with bind now? Did you build glibc with enabling CET? Did you build on the experimental malloc changes for for PAC-BTI? Like, there's a lot of things that we can gain by talking to our distributions.
Right.
So that's it.
And to make sure that I'm not being totally negative here,
Mhm.
the positive side is we've probably had more than 500 people do code commits in this last year. In that small startup that we didn't have, in the tool chain alone, we probably only had about 50 people in that. So we can do way more stuff with FOSS, with this FOSS organization, the way it's been built, than a small company could touch. So there are advantages and drawbacks to everything. And I see potential for this to continue to be the leading tool chain in FOSS.
Yeah.
In my opinion, the biggest, well, sorry, Carlos, I don't want to.
No, go ahead, Jose, go ahead.
When it comes to review buys, I mean, I understand that you are considering the reviews to be sort of a first step into getting more involved, right, in development and even maintainership, correct? Yes,
and I have more ideas on that, but anyway, continue.
Yeah, but consider the perspective of someone who actually joins a mailing list of GCC or GNU Tools or any of our projects. Reviews are traditionally, in practice, made by maintainers. So to newcomers, reviewing is an activity that what they see today in the mailing list is that who does the reviews? The maintainers, right? So I think people associate immediately reviewing as to maintainers, which is the end of the scale, right? I mean, if you want reviews to be the first step of the scale, somehow we have to remove this impression on people that it's actually an activity made by the people at the end of the scale, right? Which is maintainers. Because I have seen people who actually have had sent patches to GCC in particular and other programs. They got the patches accepted. Still, it is so difficult to convince them to review patches sent by other people. I don't know if it is shyness. I don't know if they feel that they are not qualified, as Patrick just said minutes ago. I don't know. But I mean, I agree with the idea that reviews could be a good first activity for newcomers. But
it's not necessarily a great first activity. I mean, like, the first activities are obviously simple patches, right? Actually making changes. And once you've made changes and you begin to understand a subsystem, then you can begin to do reviews. And I've had people go through that process. Now, not everybody is interested in doing reviews. And so the thing that I want to encourage is there's the submit patch. Well, camera's gone backwards. There's submit patches, start doing reviews, and then move to maintainer. That process is not as well spelled out in our communities as it might be, and that's okay. But to give a contrast, I was speaking extensively with Victor Stinner over what the Python community does. And in the Python community, there's definitely a process of coaching and mentorship that leads towards being a developer or a maintainer. And there's clarity over how that works. There's some discussions about whether someone is ready to be a maintainer for the system. We have a little bit of that in GCC and in glibc, and we have some of it kind of written out. I think with a little more structure, we might get to the point where we can make it clearer that we are definitely looking for reviews from new developers, and that practicing reviews, if that's something interesting for you, is a great way to hone your skills. Because boy, when you have to review someone else's work, you have no idea what they're talking about, it really makes you think about what does this code really do? Where's it going? Why does it function this way? What's the intent? What's the expectations? And so I think it would be great to outline a bit of a broader process for how you kind of grow in the community. And I think we have it. I think glibc has some of it in the maintainers file, and I think GCC has some of it in the in the maintainers file as well. So I think a little more work there would be great. But recording them, I think reviewed by, and accepting that reviewed by is the way we would do things, given that reviewed by has value for the process and helps the automation as well. So does that answer your question, Jose? That I think it's not the first step; it's an intermediate step, probably.
Okay, that makes more sense to me.
And that, yeah, go ahead.
No, well, that reviewing sucks. It is boring. It is actually not that easy, and yeah, I don't want to review patches. I have to, but I hate it.
And I fully expect that people on my team at Red Hat are just like, when I tell them, look, I've assigned you some patches to review, you have to review them. It's part of the way we're going to help the upstream community. That they may not like it either, but I think it really grows you as a developer when you have to review somebody else's work. Now, it's not for everybody, right? I'm not saying that everybody has to do this. It's simply that, like, if we had a path to grow reviewers, the path is a social one, it's a technical one. It's make it easy for the reviewers to review patches. Make it so that the reviewers have positive incentive, get their names recorded, so that that process works, so that when Patrick reviews a patch, it gets recorded as reviewed by from Patrick, and then Patrick can say, look, this is a thing that I got done, and it has a record, and you just keep growing. It snowballs. There's a social snowball effect there when you're a reviewer. It feels great to review more things and get thanked for the review that you do, even though it's hard and not often that much fun.
Yeah, I agree.
And I'm sorry, because I'm supposed to be reviewing a patch from Florian right now, and I'm in this panel, so.
I think Arjun has a question. Arjun?
Arjun's on my team, yeah, Arjun. What was Arjun's question? I make Arjun review patches all the time. Arjun, what do you want to say?
Okay, look. Need this.
Hey, unfortunately, Keith is listen only. Kevin, Simon, from the GDB side, what do you guys think about patch reviews and this whole process? I mean, like, we're a lot of GCC, glibc people, but like, I really want to hear from GDB about patch review. We did, I mean, between GDB and glibc, we did that Garrett experiment where we tried to like work through using Garrett for reviews. Boy, Garrett is just too hard, I think. It doesn't quite solve the problem we want. It's not as flexible as we wanted it to be. I'd love to hear from Simon and Kevin about patch reviews in GDB.
Yeah, man, Joel's online as well.
Oh, I didn't see Joel.
For me, the hardest part is keeping track of which patches have been reviewed, which one is the last one, or the one of the series, right? Like, this is the hardest part. After that, I do prefer a web-based interface for reviewing, because you can expand the patch, you can look at where it is, look at the context or more context. But yeah, at Adacore we use Garrett and we don't find it hard at all. So I think it's a question of learning the technology. The problem is that every one of us has their own, technology. So adding one more to learn can be a bit of an obstacle, let's say, for people to use the system. Because I admit that for Garrett, at least a lot of people say, oh, at the beginning it's kind of confusing a little bit, the workflow and things like this. So you have to get into it. But I would love to have for us to centralize a little bit more the patches, so that we can process the information automatically, build lists. I love also the fact that you guys have done in glibc about every week we go through the patch queue and start talking about who takes what patch. Because then it becomes a lot clearer what your responsibilities are.
Yeah. So I guess, Joel, a question for you then. Does patchwork give enough value for the cost? Which is, you can tell people, clean up your queue so that I can review your patches, is often the incentive to say, if your queue's clean and you've got the latest version in your patch in your queue, then I can review whatever patch you've got in your queue. And likewise, delegates can be recorded in the patchwork queue to know who's reviewing the patch, so that when you have that community conversation over, I'm going to review this patch, you put your name behind it, and you're the one who's doing the review until it's done. Is there enough value in that, do you think?
It's hard for me to answer the question because I haven't used Patchwork very much. I think from a procedural standpoint, probably, like if we adopt that system, we need to be clear about it and then make it work. Like we have to make an effort. And I think that's what's been lacking probably in the past. Also, from my perspective, and that might be unfair, so others will comment, but I think there's a fairly significant resistance to change in our group, and adopting new processes and things like this requires a lot of effort, a lot of energy to push, and because we all work a little bit differently, we haven't been very successful at adopting new changes.
I agree, and I think my intent because I think GDB adopted Patchwork before glibc started doing anything with it. The intent for Patchwork has been as thin as possible while providing structure that we can build upon for the community, for patch review, for patch delegation, for keeping patch queues clean, for understanding what's the next patch. Simon, you wanted to make comments, and I know I saw you unmute.
Yeah, so it was back when we were talking about Gerrit, and well, so many of you know that I quite like Gerrit. That's why I try to push it. And yeah, I just think a system like that solves many of the problems that have been mentioned today, like connecting Gerrit to a ACI system and having that ACI system like pull the change. That's 100 times easier. Sorry about the noise. It makes it a lot easier than trying to have a system pull patches from a mailing list and have it not apply. And even for humans, like there are many hurdles to reviewing, and like I try to review a lot of patches. And for example, just a newcomer sends a patch and the patch is not like formatted properly because they sent it from Outlook or whatever. Like I have to repeat that 100 times a year, and that's one of the things that deter me a bit from reviewing. So you have to kind of train people all the time, whereas like pushing a git commit, they cannot really get it wrong. Other than that, like just seeing another thing that I don't like from reviewing is reviewing different versions. When there's a big patch, it's like mostly okay. If I do comments and it's from another maintainer, I'll trust them that they change it. They just changed like what I ask, and I don't have to check the whole new version. But from somebody we don't know, like I want to see what's the difference between your v3 and v4, and like Gerrit makes that really easy. Like I can check the latest version in 2 minutes, and that's it. Whereas if it's on the mailing list, I have to reread the whole patch, and like I don't really want to do that. It's
so
yeah.
There is a tooling aspect there, right? So with Patchwork, you can just say, you can git PW, pull down a series, and git PW, pull down the second series, and then actually you do a local diff, and the local diff can show you.
That's if it was sent properly. And
but if the Patchwork try bot that doesn't apply doesn't work, you tell the contributor, you did not meet our minimum requirements for this thing applying. It's just a machine. It's just a tool. Can you please resend with the patch fixed properly? And so you kind of step back from it, and the tribot that does the patch application, it does it in the way that we all expect the patch should be applied, and it should work. And that becomes the rubric against which you can tell contributors, like, go look at your patch in the queue. If it didn't apply and the tribot didn't apply it, then you need to go fix the way that patch
if that part can be automated, like that, I would be very happy. Yeah.
It is, well, so it's automated for glibc right now. And in fact, every time we get patches that don't apply, it's usually because someone did something weird with the patch. And then I just reply and say, look, Patchwork says it doesn't apply, you got to resubmit. And they're like, oh, I didn't know, and they fix it up. Or they're patches, for example, that are cross-posted from the kernel or from the Linux man pages project, in which case we nuke them out of the patchwork tree.
Mhm. And so there, yeah, so go ahead, Fran.
But for the V3 versus version 4 review, that really doesn't solve the problem if you have sufficiently high development activity, because patchwork doesn't tell you the base commit to which you should apply your patch. And even if it applies in the past, it won't apply when you're doing your diff if there's sufficiently high activity. And this is solved by B4, I think, to some extent. But
What is that?
yeah, B4 is what some kernel developers use instead of patchwork. It goes to lore.kernel.org and can do fancy stuff with patches collected from mailing lists there.
Yes, the answer is there are race conditions in patch submission and application, and unless your submission includes a commit upon which the submission was done, in the current CI/CD system we have for glibc, we try to guess based on time at which you sent it. So we're hoping that the time at which you hit get send email was close enough to your tree that we try an application. But yeah, it's not perfect.
And that's the part that annoys me. It's we spend so much time trying to do heuristic and guessing and things when, like in my mind, this other system just gets it right 100% of the time. So, like I'm a bit like I don't want to work on trying to do some guessing. I feel it's just like a lost cause because it will always fail somewhere or another. That's my feeling.
I hear you. I think the issue is that there's a pluralist of workflows and a pluralist of views in here,
Yeah.
for which email applies best. And what we want to do is move just one step forward. And so if patchwork, for example, has a 99% success rate and a 1% fail rate for applying your patch just because it happens to have had a race condition, I'm okay with that because it really helps in all the other cases.
I agree.
Yeah. There was a question about Mark, and I do want to answer that. And Mark, you did say it's a big question. How is the relationship of the steering committees with the FSF, and how do the steering committees get new, fresh members? That is a great question. I think I can speak for myself, have a positive relationship with the FSF. We have engaged the FSF on various topics, asking for help in various areas, and I don't think that there's any anything else I would say about that. But getting new, fresh steering members, committee members, that's a question of governance, and I think that's a really big topic, and I think we should talk about that on the mailing lists. So I think if you have questions, start with a public conversation, start from a place of honesty, and we will try all to give you your answers for the questions that you have, and we'll do it on the public mailing lists in a public and transparent way.
Yeah, we're not going to cover that in 1 minute.
Yeah, sorry, yeah. I mean, that was really good. I mean, it's a really good conversation. I mean, thanks for all of this about CI/CD and the bots. I mean, this maybe should have been a BOF separate from this and not be the GCC steering committee meeting, but lots of good information to cover about this, and good for project for how the community moves forward with testing patches and reviewing patches.
Patch
But
review
we
is
are
a
up at the-
traditional topic for this.
It is. It is.
We are up at the top, and we have another presentation.
When
coming up now,
when
so
are we
we'll
going to
keep on.
convert to Git? Oh wait, we did it already.
A year ago. Yeah. So, anyways, again, thanks very much to all the panel members, all the people who serve on the GCC steering committee, and the various stewards, and especially all the developers who we're representing. Great amount of progress this year. I mean, I can't call out everybody individually, but there's been a lot of really excellent progress and excellent functionality contributed to all these projects. So thanks very much, and thanks for joining the GCC steering committee and GNU Stewards Q&A panel. And again, it's very good question from Mark, and we can, as Carlos was saying, we're maintaining a lot of us, communication the FSF and trying to have a balance between the requirements of the community and various developers and the FSF going forward, and sort of create a new path forward for all of us to succeed. So thanks very much for that, and with that, say thank you to the people from the various projects who participate in this panel, and key it up for Maxime Blinov to talk about GCC support for Darwin AR64. With Maxime around?
Hello.
Maxime, so start your camera if you want to, and hopefully Sarah can tee up your presentation.
Can I not upload it from the...
Did you give your presentation, send it to Sarah when...
Oh, no, it was a bit last minute. That's okay. I can just share my screen.
Was she giving you presenter? I think you're a presenter.
Maxim, I can't hear you.
Yeah, we can't hear Maxime anymore. He's unmuted, but we can't hear his audio anymore after.
Testing, testing, testing. Oh, does it work now? Okay, excellent. And everyone can see the presentation, right?
Yep.
Okay, good. Okay, I will F11. Okay. Well, okay, I'll just make do like this. So yes, I've said the introduction, right? So this is work that we've been doing to get the GCC working on the M1, F5. Thank you very much, Thomas. Okay, so so there's two primary. These aren't the only problems, but these are the two problems that that I'm going to be covering in this talk today. The first issue associated with this is getting GCC to run on M1 is to teach GCC about the AR64 ABI differences. So Apple, obviously AR64 ABI is well understood. It's what Linux runs on, but Apple has have a few modifications, primarily to do with how it aligns parameters on the stack. Compared to variadic ones, and we'll take a look at that next. And the second issue, which was primarily led by Andrew, tackled by Andrew, which was to how to get GCC nested functions to work without an executable stack. Now, Apple actually globally disables the execute bit for the stack. And this isn't like a code signing issue. This is just everywhere. You can't do it. And Clang doesn't support this. Clang doesn't support this, so there's no reference implementation to be able to compare to or run tests against. So this is actually quite a novel work in that way, whereas the ABI issue we can do tests against. Okay, so I'll start talking about the ABI differences with the variadic arguments. Now on Linux, the world is very simple. Named and variadic are always word aligned on 8 bytes, and the world's very flat in that sense, and GCC doesn't have to worry about these kind of things. But on a Darwin, it gets trickier. Now you've got a differentiation between variadic and named parameters, where the named is on 8 bytes, but on variadic, or rather, the named will be naturally aligned. So potentially you'll have, if you pass a unsigned short char, that'll be all in 32 bits. But the variadic will always have its full 8 bytes. So now they're laid out differently, and GCC doesn't actually have a, well, it doesn't have necessarily, there's no information available to the backend to be able to differentiate between these two. So to get a bit more detail, this primarily happens in the expand pass, where we lower calls into actual RTL. And the function, well, I won't go into the details, but specifically, locate and pad parm function in initialized argument information, which is what pass expand calls. It goes through and loops through each argument. And in the beginning, the first 6 will be just register arguments. So locate and pad parm won't even get called. Or they will get called, but it'll say, hey, put this on a register. But if you're not on a register and you're on the stack, it will call the 2 target backend functions, target function arc boundary and arc ground boundary. There's 2 more actually, but they're not important for Apple, so I omitted them. And they only care about mode and type. So there's no scope there for looking in and saying, oh, is this a named argument or anything else indeed. So this is, and the information is actually there. So on the next slide, we already have a structure in GCC, cumulative arcs. This is just a backend defined thing where you can put anything in there pretty much, and GCC will shuttle this structure around whenever there's a decision-making process that it can't make an assumption about. And the infrastructure is already all there. I mean, cumulative arcs is threaded through most of the middle end, but except for the 2 places where we really need it for Apple, which is the target function arc boundary and round boundary functions, which are obviously very core target backend hooks. So natural inclination, impulse is to just shove it into a third parameter, but well, these functions are used by every backend, so you're going to be, well, I guess that's, a bit of work with grep, I suppose, but it's a bit invasive. What's our current idea that we're pursuing is to just have to find 2 new function arc boundary macros with the cumulative args parameter. So these, just a third parameter, but we give it a new name, and the default implementation we'll just call the non-cumulative args variant. So that way you don't have to touch any of the other backends. They just continue living as they are, and they don't care about whether it's named or not. But for in RGC4 Darwin, we can override that and say, okay, if this is a named or not named, we return different kind of rounding modes. And that way we can support this world and that world, because Apple's quite unique in this regard. And it seems it would be strange to have to really dig up GCC just for one backend. And this seemed like a good balance between an invasive and non-invasive change. I'm just going to check the time. Oh. 1609. Okay, good. Right, yeah. Yes, right, okay. And I've been on that slide. And this is just a small example I cooked up to demonstrate the issue a bit more. This graph on the right is a bit confusing. S0, where you see S0, 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 S0 repeated, that's what the compiler has allocated for that parameter. From the compiler's point of view, that's how much bytes that parameter takes up. And the gray and the white difference, that shows how much that parameter actually takes up. So on AH64, everything is, as I said, is 8 bytes aligned, naturally aligned, word aligned. So it doesn't matter if you've got a 64, 32-bit, the compiler will just give you 8 bytes on the stack, and everything works, and it's easy. Now, initially, if you just then take the Darwin port and just try and, without any of the hacks that we've done, and just tell if you just flat align it, naturally align everything, you'll get the wrong answer, because GCC will then start putting things into 32 bits, where variadic should be 64 bits. So it naturally aligns the named stuff, which is fine, but the variadic stuff shouldn't be aligned. It should have its own 8-byte slot each time. So this is sort of the naive approach, which will result in binary incompatibility. And what we really wanted, there's a third example, is to have everything that's named naturally aligned and everything else be, I think I'm messing up my word aligned and naturally aligned. Well, anyway, and everything else be word aligned. So this is the kind of stack layout that we're looking for. So if it's named, you can put stuff a bit closer together, but if it's variadic, we just give it flat 8 bytes each time. Okay, and this is just some of the tests we've done. So this is bootstrapping now on M1, and specifically some of the useful tests have been compat and struct layout, which are basically fuzzers, or sort of, that we could compare against. So it does A/B tests. So it takes an object file, compiles it with compiler A, and then the second object file compiles with compiler A, links it and runs it. Then AB links and runs, BA links runs, BB links runs, and obviously A is like Clang, and B is our GCC port, and we're using that to sort of base how healthy the compiler is looking, and it's looking to be a relatively non-invasive change at the moment. Okay, and the second feature I'm going through is the nested function support. Just check my time again. Okay, I'll assume I've got a few minutes left. Clang has the Apple has the problem that they've marked this, well, not a problem, but they've marked the stack as non-execute, which is a problem for nested functions. You need to put the trampoline on the stack, and you need to run it, you need to mark it as execute, and Apple doesn't let that. So this is work primarily led by Andrew. Well, our idea is to actually mmap pages in at runtime to hold trampolines. And this is still a prototype idea. There's some questions left, but there is a working prototype that we have, and I'm just going to go into a few details about how, as I understand it, it works. So there's two sides of the notifications that we've done, which is for libgcc, there's two new functions, which is function to create the nested function and to delete it. In libgcc, we've added a new thread local sort of root page, which is always present, and it will contain basically the is location where we can chain on trampolines at runtime, or play locations in memory for trampolines at runtime. And we can mark that as execute, because mmap marked as executable is allowed. And for the GCC side, on the front end, in the place where we lower the nested functions, we've added those built-in calls to those built-ins. So every time we enter a function that contains code which has a nested function, and we take the address of it. So that is to say, we have a nested function that we're using, and it escapes our scope. I think that's as I understand it. We emit calls to allocate a pointer to this nested function when we enter it for the trampoline, and then call it again to clean it up after ourselves. And this then goes into the libgcc code, and libgcc will either reuse the root page because trampolines aren't that big, or if we're out of memory, it'll it'll allocate a new page, mark it as execute, and chain it onto the root page. And this bypasses the need for an executable stack. So it's quite a neat solution. So in summary, these aren't the only issue. These are just, as I say, the two features that I've been talking about in this talk. There's a few others that I haven't gone over. In conclusion, though, for the variadic argument, it's pretty much functional. There's some regression tests that need to be squashed, but it's not, as I say, not a very invasive change in the end. The mmap trampoline implementation is still a prototype, and there are a few questions regarding, as I understand, how it behaves when you've got a long jump set up, or when you're exception handling, you're unwinding. I'm not sure what the conclusion was on that, but the idea is that there may have to be restricted support. So we may have to say that on Darwin, if you're using trampolines, some things might not work as you would expect on x86, for example. But that's the state of that's what I wanted to say, and that's the state of our work at the moment. Thank you all for listening, and I will try to answer some questions if there's time.
Yeah, I think there's a question from Jakob about leaking trampolines on long jump out of a function.
But that was in the slide.
Okay.
I do recommend to Ian and Andrew are experts at this particular code aspect.
Yeah, unfortunately, that we didn't yet find a solution to the long jump in a general case. There may be cases in which you can successfully clean up, but not all.
Okay, well, if there are any other questions, people go to I mean, contact Maxime or Ian directly, and thanks Maxime and Ian and everybody for the great work on this to enable AR64 Darwin in GCC. It's a lot of a great plan, great progress. So thanks very much for this great work and contributing to GCC.
Can I just say the kudos actually partly goes to the Fortran team. The huge driver for this is coming from the Fortran side, in fact.
Excellent. Very glad, glad that there's a lot of pull and requirement for this, and that we're continuing the progress. So thanks to the Fortran team as well, as Ian said. So thanks, Maxime, very much for this presentation, this update.
Thank you, David. Thanks, everyone. Right.
And now moving on to Patrick Biggerty, who's up for his third presentation. He's trying to set a record at the GNU Tools Track. So welcome, Patrick, for your next presentation about optimizing multi-core or single core and shared cache.
All right, let's make sure I've got audio. Can you hear me?
Yep, can hear you.
Good.
Can see your slides.
Good.
Excellent.
All right. The broad question that I put up on the slide is, do you optimize for multi-core or single core? Many developers do their primary work on desktop. Another segment of developers do their primary work on large shared systems. But we're a library. We have to do both. The particular case here, well, just to give some examples, modern chips, and if you took your architecture classes 20 years ago, this was not so much true, but modern chips, take an example of the Intel Ice Lake Xenon Platinum 8380 has 40 cores, 80 threads, 60 megabytes of L3 cache. What a massive amount compared to my early work. Shared by all threads. Now that's only 3/4 of a megabyte per thread, which seems a more reasonable amount, but still that's a pretty big spread between the total versus what one thread earns. The AMD EPYC, a slightly newer chip, has 64 cores, 128 threads, 256 megabytes of L3 cache per chip, split up into 16 segments, each of 16 megabytes. And that comes to 2 megabytes per thread. It's pretty common for server class chips these days that have many processors to share the L3 cache against some or all processors. Those two examples are not unique by any means. The particular issue that got this to my attention was that the x86 architecture supports the concept of non-temporal stores, at least the more recent architectures do. It's a hint to the hardware. When you use the non-temporal store instead of an ordinary store, don't store the data. Well, it's known that the data is not expected to be read again soon. So the implementation can choose to either put it in cache or not put it in cache. It's also called streaming stores, because you only can bypass the cache when you have enough stores to essentially replace all the current all elements in the cache line. Implementation can be tricky, but hardware guys are pretty smart these days, and they've done it. The benefits are you don't push other data out of the cache when you do one of these streaming stores. And you may reduce memory traffic because the cache line that you're filling up doesn't need to be fetched. You just have a side buffer that sends the new elements of the cache line out to memory, well, without ever pulling in the previous elements. The drawback is you may reduce opportunities for cache reuse when you've got very large caches available. Basically, when you're doing a streaming store and you don't, and you have more cache than you need for ordinary purposes. So what brought all the attention? Performance issues. Obviously, this is a performance application. It doesn't change the correctness of the application. There was an optimization patch to glibc memcopy several years ago that was tuned to provide maximum improvement for single thread performance on an 8-core system by increasing the threshold for when you do non-temporal stores. Basically, it's saying don't do non-temporal stores so you get more hits when you can. Sometime later, the upstream code got put into a downstream distribution, and it was observed that the new threshold prevented non-temporal stores on the highly parallel stream benchmark that caused a 20% performance regression when run on a 128 core system. And that was because all 128 cores were active, and they were all trying to use that same cache, and they were getting in each other's way. In other studies, I did some surveys of the web and found some notes that suggested large copies that clear shared cache can cost 20% performance when you're interacting with a pointer chasing application, something using any sort of linked list management will chase pointers. So the critical thing to note about this is you lose the performance most often when the system's on its highest load, when you least want to lose performance. That contributes to falling off a cliff and massive increases in latency in client server applications. So what do we do about it? Here's what the situation was. The old threshold was hard-coded 6 times 1 core share of the L3 cache, and it was based on early 8 cores per chip kind of assumptions of about 10 or 15 years ago. The changed code that brought the attention is now you're allowed 3/4 of the total L3 cache for a single thread. And that was based on single thread benchmarks that were used to tune. A perfectly reasonable approach if you've got the desktop mindset. So the new threshold is the new computation is saying memcopy can use 3/4 of 1 core share of the L3 cache. You want the other 1/4 to remain available for your active working set for the application. So when you return from the memcopy, you've still got whatever the current data that it's working on in the cache. The current glibc philosophy is that activity on one thread should not cause significant negative effects on other threads. You can think of it as, for example, in any of the cloud situations, you've got virtual memory, virtual machines, virtual environments that you might have 8 cores assigned to you on a chip that has 128 cores. 16 other applications are using this single chip. You don't want, or 15 other ones, you don't want those 15 other people to gobble up your share of the cache. And as this was to be a lightning talk, I have completed the material here. Let me see any comments in the chat room that need to be responded to. Any questions at this point?
So is this for x86 or some other architecture?
It's for any architecture that is x86 compatible. That would be AMD, and x86 would be the best known.
Okay.
The non-temporal stores are an x86 specific issue. So the code change was only in the x86 sysdepends branch.
But it's worth noting that the model for the L3 cache that Patrick's describing is the same model they have on the IBM Z series now. So the concept of where he's trying to go with this applies much more broadly.
No, I think I was making a more specific point that I think the mem move for x86-64 uses a tunable for non-temporal threshold.
Okay.
It's dynamic, and you can actually tune it according to the workload that you're using. So that might be one way out of it. Although defaults may be a much deeper discussion.
Yes, and if somebody is doing their own streaming loads and stores that don't call the library routine, a single thread could blow everybody's L3 cache, the entire chip's L3 cache.
Yep.
So we have not solved that total issue right here.
We
But
just don't want glibc to be the cause of this anymore.
Right. And I note in the comment about string functions can also have this kind of issue.
Yeah, which is why perhaps making the threshold dynamic and having workloads decided might actually be the way out of it, because I don't see how we can comprehensively solve this inside glibc.
Yes, but we may want to look at the other string functions for x86 specific and see if they could benefit from non-temporal stores as well, or any of the modification functions. Memset may have a similar issue. I haven't looked at any of that code. The real point of this talk was to bring the concept of oversharing or overuse of a chip's cache by a single thread as an awareness issue.
Yeah, I think Wilco had done some study probably a year or two back on string functions, not the mem functions, where he found that a majority of the workload for the string functions are usually short to medium strings. So you're not really frequently doing very long string copies. Mem copies are a different issue. Mem copies, mem sets, mem moves. You frequently have large blocks. So having a non-temporal threshold over there is a lot more variable than in the string functions. But yes, it's probably something that needs to be codified somewhere, either in the wiki or in some sort of a paper or something like that.
Right. And as Nick notes, when you're single threaded and it's the only live thread, then it's not overused to hold the whole cache. But in a cloud virtual environment, there's no way to know whether you are the only user of the entire chip. But if you're in a dedicated own the system, high performance computing kind of environment, then there are times you know that you're doing the communication. When you're copying blocks of data for all the other threads to get to work on, you want to do it as fast as you can. Lots of different situations, and so tunables could be a good long-term answer for those people that have unusual single thread needs.
Yeah, and on a related point, the source of this problem that you're talking about is the fact that we optimized for single thread. And one of the things to blame for that is probably the benchmarks. The glibc bench tests are overwhelmingly single threaded, so we probably need more coverage there as well.
I think we're near the end of our time. I have us at 10:29 my local time, so might as well
thanks very
let
much,
the next
Patrick.
talk get started. Yes.
Thanks for a very interesting, insightful presentation. Lots of good conversation, good ideas about how to move this forward. So we definitely need to think more about caching and memory usage and virtual machines and dedicated machines. There's a lot of challenge of how to find the right balance for all this. So thanks very much for raising this topic and for pursuing this issue. Thanks very much, Patrick.
Thank you. I'll drop off now, or well, I still like to see the next talk, but I will I will mute now.
Right. So invite King Zhao.
Hi, can you hear me?
Yes, we can.
Oh, okay, that's good.
Great. Welcome. Thank you very much for joining today, and I'll let you have the floor now for your excellent presentation.
Okay, so can you see me?
Yes, we can.
Oh, okay, yeah. Hi, my name is Qin. So my talk today is security improvement in GCC. How to? Okay, yeah. So I'll start from the a security wish list that was requested for the Linux kernel for a long time, and then we choose two of the important security feature to implement it and add it into the latest GCC. These two features, the first one is core used registers wiping on return, which is added to GCC 11. And the second one is stack variable auto initialization, which is added to GCC 12 recently. And then after that, some future work. There are quite some security feature that was requested for the Linux kernel for a long time. So this is a list which compare the GCC and the clone on a set of the security feature. So there basically the wish list include speculative load handling, core use register wiping on return, and stack variable auto initialization, and structure layout randomization, and etc. Yeah. So some of the features has been in other compiler, for example, the clone or Microsoft compiler for some time. For example, the stack variable auto initialization has been available in other compiler already. But GCC missing those features, and yeah, this makes it GCC less competitive with other compiler in the security area. So for over one and a half year, we have been working very hard in this area to try to make GCC comparable or work even better than other compiler. So I'll talk a little bit on the first feature we added into GCC. It's called core use register wiping on return. I'll start from the motivation first, and then several important questions and the answer. After that, the new feature added to GCC 11, status of the patch. Then I will conclude the first feature with a summary of the implementation detail and acknowledgement. So why this feature? Yeah, why we need the core use register wiping on return? Mostly there are two major purposes. The first one is to mitigating return-oriented programming attack technique. The second one is try to prevent information leakage through register. Yeah, so there are this is a two major purpose for this task. So why the core use register wiping can mitigate ROP? We need to understand the features of ROP first. So for ROP, that's a return-oriented programming. It's one of the most popular code reuse attack techniques. And ROP usually execute gadget chains to perform malicious tasks. So a gadget chain usually is a carefully chosen machine instruction sequence that already in the existing memory, machine memory. So each gadget usually ends in a return instruction and located in a subroutine within the existing program or shared library code. One important feature of the RLP is the destination of using gadget chains, usually call system function to perform malicious behavior. So the registers usually are used to pass parameters for these system functions. So we can see the return instruction. Before the return instruction, the register might be used for passing the parameter to the system function. So this is a major feature of the gadget of the RLP. So yeah, after understand the feature, we know if we clean the scratch registers that are used to pass parameter at return instruction, then we can break the gadget chain and effectively mitigate the RLP attack. So for more detail, you can refer to this paper listed in the bottom of this slide. The second motivation is to prevent information leakage through registers. One of the well-known security technique is stack and the register erasure, which ensures that on return from a function, no data is left on the stack or in registers. Actually, there is a separate patch. I remember this as an old patch address the stack erasure problem, which has been submitted, but I'm not sure what's the status right now. But for this core use register wiping task, we can address the register erasure problem at the same time. Yeah. After understand why we need this feature, we then need to answer two important questions to decide the design. The first question is, which registers should be cleaned at the return of the function? The short answer is the caller saved, that is core used or core clambered registers. Actually, for RLP mitigation purpose, only the core used registers that pass parameters need to be cleaned. That should be enough for the RLP mitigation. But for the register erasure purpose, all the core used registers need to be cleaned. So yeah, because there are different security need for different user, and also there are also the runtime overhead issue we need to consider. So we should provide multiple levels of control to the user. And then the second question is why we choose to zero the registers other than randomize them. The short answer is first, zero tends to be the safest choice, as it's less useful to be used as a meaningful size or an index or a pointer. And secondly, because usually generated machine code for zero is faster and smaller than the machine code for other non-zero constants. So we choose to use zero to clean the registers. After answer those important questions, yeah, we now know what kind of interface functionality we need to add into GCC. We add a command line option along with a new matching function attribute. So it's called F0 core use registers with a sub option to choose the subset of the core used register to be cleaned. So this option for choose the subset, yeah, it's basically there are three basic choice. It's skip, used, and all. Skip means none of the core used register need to be cleaned. Used means those register that are used in the function need to be cleaned. And all means all the core use register should be cleaned. So in addition to these three basic choices, we have two more modifier can be added to further restrict the core user register set. The GPR to restrict into the only the general purpose registers, and the AIT is added to restricted the register that can pass parameters. So with the three basic choice and these two modifier, we have a combination of total 9 combination to choose which subset of the core use register should be cleaned. So we can provide a multiple level to the user to choose. So this patch has been committed to GCC 11 on October last year, and it's the original commit has a full support for x86 and Arch64, and on x86, an optimized implementation was provided. Later on December last year, Spark was supported by defining the new target hook, target zero core use registers. Yeah, and this year on June 9, the Linux kernel was configured to use this feature to improve the kernel security. So yeah, so let's take a look of a little more detail of this patch. So for this patch, we add a new path and also a new target hook. So the new path is added in the beginning of the late compilation. It's called path zero core use registers. In this new path, we scan the exit block from backwards to look for return. And for each return, we compute the hard register set, need zeroed hard register based on the user request from the option, the data flow information to compute whether it's used or not, and the function API information to see whether it's a core used or it's a parameter, it's a parameter passing register or not. Yeah, and then we pass this computed hard register set to the new target hook, and to generate the instruction sequence, zero the register set. Yeah, so that's the new path. And for the new target hook, the default implementation is in the middle end, and it will generate a sequence without ending target specific optimization. Yeah, but on the x86 backend, we provided a optimized implementation for the target hook. Yeah, this is quite big project, and this took over half year to finally commit it. During the discussing and patch revision process, yeah, a lot of people provide help and idea, help me go through all the every problem. So yeah, here I really appreciate all the help from people from the community. Thanks a lot. Yeah. So this is for the first feature. And the second new feature we added into GCC is stack variable auto initialization. We also start from the motivation and then the new feature added. And after that, a status of the patch, and then concluded with a summary of the implementation and acknowledgement. Yeah. Yeah, so for the stack variable, yes, there are quite some of the popular language, for example, C, C++, the stack variable is not initialized by default. So for an initialized variable, usually it's hold a junk data before, which is in the memory before the function was invoked. So the junk data in the initialized variable might result in incorrect computation or change the program behavior unpredictably. And sometimes the attacker can pre-initialize the uninitialized variable in order to enable some malicious code execution. And also, if a stack variable, an initialized stack variable is a lock variable, it might cause a race condition. Yeah, so it's quite dangerous with an initialized stack variable. It might have some other bad impact as well. Yeah. So we need to fix all this uninitialized variable because it's a very tedious work to identify all the uninitialized variable in the a very big software product. So tools are needed to detect the uninitialized variable. Currently, we have basically we have static tools and dynamic tools. For the static tools, for example, for GCC and Clang, they both support the initialized variable warning. And for Visual Studio, it provides an analysis plugin for this purpose. For the dynamic tools, both GCC and Clang provide the address memory sanitizer, which catch the uninitialized variable during the runtime. There are also a standalone tool, Valgrind, which also for this purpose. Yeah, so there are quite some tools available right now, but there are some limitations for all these tools. For the static tools, because there are some limitation of the analysis. For example, first, because most of the static tools based on inter-procedure analysis, so it has to assume the code function initialize every parameter. Yeah, and also inside the function, there also has some limitations for an initialized array or initialized pointers due to some values index might only be known during the runtime. And also there are some potential infeasible paths due to the conditional expression cannot be evaluated statically during compilation time. So yeah, as a result, the static analysis tool usually has the major issue is false positive. Of course, there are still false negative at the same time. Yeah. For the dynamic tools, the major issue is false negative because the dynamic tools usually catch the issue during runtime, but runtime it cannot execute all the possible execution paths. So the major issue is false negative. Of course, there are some occasionally false positive issue. Another big issue with dynamic tools is the runtime overhead. It's quite big. And also the size of the log are very large and had to be analyzed. So yeah, due to this limitation of the available tools, it's impossible to detect all the uninitialized variable before the final production. So there are still some missing case that for the uninitialized variable in the production, software production. So there is a need for the compiler to automatically initialize all the uninitialized variable during compilation time for the production build for security purpose. Right now, both Microsoft compiler and Clang already support this feature. They provide compiler time, the first class option to provide zero or pattern initialization. For the pattern initialization, it's used in the development build for debugging purpose. For the zero initialization, it's usually used in production build for security purpose. Yeah, so both the Microsoft and Clang supported, I think, last year. Yeah, but the GCC missing this this feature. So for this year, we have start working on this feature and have a long discussing start the beginning of this year till now over several months, and finally we decide we agree on the final patch and add to the GCC 12. So the new features added to the GCC 12 is the user interface is quite simple. It's just a new GCC option along with a matching attribute for variable. So this GCC option is trivial auto variable initial. So the name is exactly the same as Clang in order to comparable with Clang. And there are three choices for the initialization. The uninitialized pattern and zero, and default is uninitialized. Means doesn't initialize any variable. Pattern will initialize with values that will likely transform logic bugs into crashes. So this is mainly for the debugging purposes. A zero will initialize the static variable with zeros. It's usually should be used in the production build. So the attribute for variable is mainly for performance purpose. The marked variable is uninitialized intentionally. So for example, if there's a big array, a stack array, you know it will be initialized manually in the function, and you don't want the compiler to automatically initialize it. You can use this attribute to mark it to improve to avoid the performance penalty. Yeah, and the third feature, we need to keep in mind is this new feature, new option will still keep the current static warning on an initialized variable unattached. So that's our goal. So in order to avoid forking the language issue, there are a lot of discussing in the very beginning of this task to complain this feature might fork in the language. So we need to, okay, thank you. This patch is committed to GCC 12 2 weeks ago. Yeah, so I'm happy with that. But after the initial commit, there are some bugs filed and fixed. Yeah, and also there are some bugs filed but not fixed yet. Thanks a lot for Richard Burney to help me fix the first 3 bugs. And there are still 4 bugs, open bugs remaining for fix. I will work on them after this LPC conference. Yeah. Yeah, a summary of this patch. So we have 3 major requirements for the patch. We need to initialize all variables, including the structure padding. And we need to keep the static warning unattached. And we need to minimize runtime overhead. So in order to meet all this requirement, the implementation becomes not a trivial task. So after long discussing, we finally decided to introduce a new internal function to represent the initialization. Yeah, so yeah, I will skip the detail of this initial function. And in the simplification phase, we add the call to initial function for every auto variable that does not have a explicit initializer. And during the RTL expansion phase, we expand this call to this internal function to the real initialization. And in order to maintain the uninitialized warning, we need to adjust the uninitialized variable analysis phase with the new defs to this internal call. Also, in order to minimize stack usage, we need to adjust the Scala replacement phase with the new calls to this internal function. So there are also some other change details. I'm not get more details there. So yeah, also for this task, it's very involve a lot of discussing, involve a lot of different compiler phases. So people from the community provide a lot of insight and idea help during this process. So many thanks to all the people help me. Yeah. So some future work. For core use register wiping, currently there are 2 open bugs need to be fixed first. And then after that, I believe when more people use this feature, there will be some potential correctness and the performance issue will be reported, and I will address them when needed later. Yeah. And for stack variable auto initialization, there is one known issue need to be addressed first. So we all know this issue before the commit. That's missing warning, uninitialized warning for address taken variable. I think the fix should be in the uninitialized analysis phase. I have a plan to fix it as soon as possible. And there are some open bugs need to be fixed. Yeah, mentioned in the previous slides. And I believe more potential correctness and the performance bugs might be reported later when more people use this feature. Yeah, so yeah, so that's it for my talk. Any questions? I'll happy to take.
Jing, hi, it's Jose. I have collected some questions that have been made in the chat in the shared notes.
Oh,
but it's easier for you to find them.
Where? so many. So many. So,
No, but if you look at the shared notes.
Oh, shared notes. Okay,
yes.
Okay. Thank
I
you.
have extracted the questions for you there.
Thank you. Thank you for that. How does core register wiping perform compared to control flow integrated? Question: Cloud performs local initialization in the front. How is it? Yeah, there's a question from Alexander. Cloud performs local initialization in the front end. How is this done in GCC? Also, do you have any performance data for GCC implementation? Cloud performs this initialization in the front end, and it didn't introduce any internal function, as we did, because they provide their initialized warning analysis is also done in front end, and they have a good data flow analysis in front end. So that's very surprising me. So for GCC, because our initialized warning analysis is in middle end, and it's also quite late. So we have to introduce a new internal function for this purpose. So that's the complicated part of the GCC implementation. So because Cloud has a data flow analysis in the front end, so but we don't. Yes, I do have performance data in the very beginning of the design, and I provide that performance data to the GCC patch alias, and I can get that data if you are interested, and send to the GCC alias. And the performance data is good. I think it's not very. I think the performance data, we think it's good. At that time. Another question: does register erasure work across long jump or C+ throwing? Does the register erasure work across long jump or C++ throwing exception? I think this register erasure, that one, we only erase the register at the return instruction. So not sure whether it's work across the long jump or not. I think we during the choose which procedure need to be do the register erasure, we already exclude those functions with the long jump. That's my memory, but I'm not quite sure on this. I need to check. I need to check. How does Alexander has another question: is how does core register wiping perform compared to control flow integrated instrumentation provided by Cloud? Register wiping perform. You mean the register control flow integrated? Actually, I didn't compare these two techniques before, so I don't have a good answer to this question. Not sure anyone else has a good answer for this.
I think we need to take that offline. We're sort of getting over time. There's a quick question if Florian has, but no more questions in the shared notes, please.
I think we can update long jump, the implementation of long jump, to clear the registers unconditionally at the 3 or 4 additional instructions there, and then you always come out of the long jump with those registers cleared. Maybe that's an option.
You mean include the long jump, right? Currently, we might exclude it, but we might need to include it for the completeness, right?
Yeah, it's an assembler implementation on most targets, I think, and we can add the additional register clearing to the assembler implementation of long jump.
Yeah, I think that might, but that should be done in the middle end, right? For the long, currently we scan the we find the place we need to clean the register during the middle end. So at that point we choose which function, which return we need to insert the register zeroing. So that should be done. If we want to include the long jump, we might need to done it in the middle end. That's the target, the target hook part.
I was thinking about the long jump function, not the GCC built-in of the same name.
Yeah, long jump function.
It's in glibc, so that you wouldn't change GCC for that.
Oh, okay. You mean just for the long jump function itself?
Yeah.
Oh, okay, okay.
Then you don't have to clear things before you go into long jump.
Yeah, yeah, that makes sense. Yeah.
Okay, thanks, Florian, for that suggestion. I think we're over time now and should give people a couple of minutes for the planned break now.
Okay.
So let's take everything else. Thanks very much, Jing, for your very interesting presentation. Glad that you're working on this improving security so that the GCC and Clang and the Microsoft compilers are all equivalent on this. So we'll take a break for about 7 minutes left and start again at 7 minutes, 15 minutes past the hour for the next set of presentations for the second half of this track. So thanks very much. Great talk, great presentation by everybody. And again, thanks to all the great sponsors of the Linux Plumbers Conference this year.
Hey, Bill.
Hi, how are you?
Good. How are you?
Good. Glad you can hear me.
Yes, I can.
I take it you're moderating. Appreciate that.
Yes, I am.
Hey, Saker.
Hey, Jeff. There you go.
Hi, Gamafi. How you doing?
I'm okay. How are you?
I'm doing all
Nice
right.
to see you
Settling
again
in.
after a few months.
Yeah. I'm here to listen in on what the competition is doing.
Oh, is that what we are?
Yeah.
So you think we're going to say a lot?
I don't know. I'm not going to say anything.
I mean, do you think we do a lot?
Sure, I thought Jeff was here to offer some sweet jobs working for him. But...
No, we do have positions open. I have explicitly not recruited from my contacts. I didn't figure, leaving and recruiting your colleagues, a few months later is probably not the best way to go.
Yeah.
It'll eventually catch up with you.
It will. I'm not sure if we're seeing Michael's desk, the ceiling, the floor. Oh, wait, there's Michael underneath.
Yeah, he's under his desk today. That's it's been one of those weeks.
Hi, Michael.
Hey, Mike, can you? I think you're muted, so if you want to say anything, come on off. Is Sarah out there? Are you gonna put the deck up, or?
Well, let me just say before we start to again thank all of the great sponsors for this Linux Plumbers conference. Diamond sponsor is Facebook. The platinum sponsor is IBM. Gold sponsorship from ARM and Microsoft. And silver sponsors of Amazon, Netflix, and Red Hat. And speakers gifts provided by Collabora, and the t-shirts provided by VMware. And the organization of all of this by Linux Foundation. And again, thanks to Embicosm for their organizational skills and administrative help with the GNU Tools Track itself. So thanks very much for all the people helping to make this conference possible and successful. And so not sure who's the
I am the moderator for this session.
Gautam, so over to you. Thanks.
Okay, thank you. Thank you, David. Thank you, everyone. So welcome everyone to the second part of today's session. We have Bill, Sagar, Jeff, and Michael. I'm going to hand it over to you guys for the PowerPC BOF.
All right, thank you everybody, and happy solstice, and welcome to the PowerPC BOF. Let's see. I am trying to figure out how to make this go to the next slide. Oh, there, I think it's over on the right. Huh? No.
You can just use the arrow keys.
Well, that's what you would think. Oh, they're down at the bottom. Thank you. Thank you so much. I'm just not familiar with Big Blue Button. All right, so we put together a few topics here that we can speak about, but this is not intended to be us driving the conversation. This is us listening to what people want to talk about with PowerPC. So I did prepare a few things here. We do have support for the new Power 10 processor in GCC 11. So if people are interested in some of those details, we can talk about it. Sagar knows the most about the microarchitecture. There's some new prefix instructions. We now have 8-byte instructions in addition to 4-byte instructions in the architecture. That's a first. We've added a PC relative addressing mode, and for that we needed to update the ABI. There's a brand new matrix multiply assist feature in Power 10, which is pretty interesting. And Peter Bergner did the compiler support in GCC, so he's available to talk about that if you'd like. We did add some ROP attack mitigation support into the architecture in Power 10, and we've got that supported within GCC and GCC 11 as well. Other things that came up in GCC recently that are kind of interesting. One is there's a patch that one of our newer developers, Gui Hao Chen, came up with something to eliminate mode promotion that was being done accidentally. This is one of these cases where somebody with new eyes managed to find something that has been plaguing us in the back end for a long time, and this was actually
for a very long time. It was there in the very first commit for PowerPC.
Yeah, it's been there forever. And as a result, just making this basically a one-line change to the back end gave us about a 2.5% improvement in spec ends, among other things. So that was really nice to see that finally get fixed. One of the things that we've seen, fairly frequently there is inexplicable, unnecessary sign extensions that would show up in the code, and we could never quite trace down where they were coming from. This turned out to be the reason, something a little macro during expand.
Only part of it, unfortunately.
Yeah, so we can talk more about that if you guys like. There's another project that I'm personally involved with, the built-in function support in the back end. Over the last 20 years has become somewhat untenable, completely difficult to maintain, very easy to make mistakes as you're adding new built-ins. So I've taken it on myself to try to rewrite that, and I've been plaguing Sager with way too many patches to try to get this fixed. But hopefully by the end of GCC 12, we will have a brand new system that will be much easier to use. Currently working on this PSABI issue that Jakob identified. There is a problem with C++ zero-length fields that should not have been eliminated. The fact that they were being eliminated meant that we thought that things were homogeneous aggregates that were not homogeneous aggregates, and therefore we were passing them in floating point and vector registers, and we shouldn't have been, and we're working on putting out a warning that this behavior is changing back to what the ABI says it should be, which is that we don't do that. IEEE 128, this has been going on for, Mike, how many years?
I've lost track. I think it's 5.
Yeah, so this has been a really long project. And guess what? It's kind of approaching the end because all the patches are in. And really, it's a matter now of being able to try this out and flip a switch and turn this on so that we will have IEEE 128 as the default long double support instead of having the IBM double as the default long double support.
That's only for Power 9 and later, because other systems do not have the hardware support.
Well,
right.
It does work if you do Power 8, but we would prefer people to do it only Power 9 and above.
Do it on Power 8 for if you have VSX and Power 8. Yeah. But I would like it to actually be used in all APIs always, so we can get rid of double.
That is the ultimate goal. Yeah.
Double must die.
So some of the things on our horizon for this is, go ahead.
Well, we can make it die in our 6000 port, right? But it will still exist in the mid port. We cannot make it die in just our backend.
Well, it's still going to be used in AIX indefinitely.
Yeah, as well.
So it's not going to die in the RS6000 port either.
Yeah.
Good point. Yeah.
But we won't have to use it on anything that doesn't care about compatibility to the old ways.
We actually want to try this out in a distribution, and right now I think we're going to play around in Fedora 36 as a possibility. At least we're exploring that as one place where we could turn this on for a whole distribution and make sure that we don't have, I'm sure there will be some fallout that we'll have to figure out what's going on, but that seems like our first best attempt.
But only for little endian L version 2.
Yeah, it's
Yes.
only little endian. And one of the things is things like Fortran are not backwards compatible across the different long double types because they do not have the support in the library for both long double types, unlike C and C++. So it will tend to be at a major thing where you're not expecting backwards compatibility.
Yeah, in Fortran they still use kind equals something, where that something is the size of the floating point type. Which is not good enough for us. We should have like 16 for IEEE quad precision probably, right? But then 15 for double or 17, or I don't know, 42 doesn't really matter. But some other number.
Well, it's ingrained in the compiler. It's all the way back to Richard Stallman code, and just trying to find these hidden things is problematical.
Yeah, but at some point it will have to change in Fortran as well. Like we have two separate 16-bit floating point types. So.
Well, actually, I think it's 4 if you count all the different implementations.
Well, yeah, there's at least 4, yeah, but there's 2 that are used a lot. There's IEEE and there's the brain float.
So that's one topic we can go into more if people want to. Then there's also been some interesting things going on with glibc. Tulio and his team are here to talk about that if folks are interested. A fair amount of optimizations done for P10 in particular with string and mem functions and some other things. There's a new system called vectored instruction that requires libc support that's kind of interesting. Tulio's also been working on the side to help with the microwatt port, which is kind of interesting because this is something that doesn't have a vector unit. So at least to be able to run some tests, he's been removing some barriers from glibc. And we're never going to be able to totally remove vector support or vector requirement from glibc for PPC 64LE. That would be a violation of the whole ABI and everything. But Tulio's at least been helping out there, and he can talk about that more if he'd like. And then I did mention this matrix multiply assist unit, and in addition to the compiler support, then we've been working on building that into some of the open source AI libraries. We have a team that's been working in OpenBLAS and Eigen, the Onyx runtime, Bliss, a variety of places where this support can be used to improve performance. And we see some really nice speed ups there. And we have Raji here who can talk to that if we like. So. And then there could be lots of things that I haven't thought about that we could talk about. So that's the what else bullet. So at this point, I'm going to shut up and let you guys talk and tell me what you're interested in hearing more about or talking about.
Very quick question. Presumably the PSABI issue affects 32-bit legacy targets as well?
No, it doesn't. This is only for the LV2 ABI 64-bit.
So what about my 64-bit ABI, which does do homogeneous aggregates?
Okay, so yeah, you'll want to review that then and make sure that what we're doing is appropriate for you as well. Because if your assumption is that a homogeneous aggregate does not include a zero-length bit field stuck in between the things that are otherwise homogeneous, then there will be a change in behavior going from GCC 11 to GCC 12.
Yeah, I need to check my argument lowering code for that. We have funky stuff for the 32-bit one where we check all the various things, but I think the 64-bit's much more straightforward.
Okay, yeah.
There's a patch for it right now that I need to review still. But it actually uses a hook in the generic code, so you can use the same thing.
So the PR number you should look at is 102024.
02024. Okay, thanks.
Yeah. And Jakob looked at my patch and has questions, so I have to wait until, once we're done here today, I have to go and see if I've screwed something up for C. I didn't think I did, but I have to go check. This is primarily a change for C++, by the way. It's the change of behavior is there.
Yeah, it's only a C++. Yeah. The problem was that C++ front end removed the zero length bit fields, so the backend didn't actually get to see it. And it has to see it. So, yeah.
I remember some changes where we made, which we did make to the 32-bit code handling, that when the zero length or the no address of kind of option came in. I've just forgotten the C++ name for it right off the top of my head. We did make some changes for that for both 32 and 64. So.
Yeah, I mean, I'm not going to say there's nothing wrong in your 32-bit. I'm just saying that, it's where we ran into it was with the homogeneous aggregate situation. There's always the possibility that you've got some other dependency that you should look at. So. But Jakob's laid out fairly clearly in that PR what the change was that he made for GCC 12, and that's where we've been discussing what the different backends need to do about their ABI issues.
Okay, thanks.
Yep.
The only thing we do, I think, Bill, is warn about the potential problem, and we just
because actually, reinstating the zero length bit field allows us to do the right thing, which is to not use a homogeneous aggregate. And so previous versions of GCC were wrong. So now we're just going to warn on the new versions.
Yeah, and no one noticed that they were wrong either. So
this is an extreme corner case that I doubt very much in practice is an issue.
So we still have a warning that GCC 5 changed one of the behaviors of the ABI and so forth. We removed that recently, right?
Yeah.
We're removing that in GCC 12. Yeah. We're finally getting rid of it. I removed my hesitation about removing the warning. And I thought, maybe we should wait until nobody's using 4.8 anymore. But, I think maybe we can give up on that. That's just waiting too long.
I don't know if GCC still builds under 4.8 anymore.
It does.
Barely hanging on.
I still use it, so yeah. I use the oldest version of everything that's still supported to build everything.
Okay. Anybody out there have other discussion points that you'd like to hear more about, or we should talk about?
I'm curious about your MMA support. Let's see, what can I say and what should I say? We have something similar. We're looking right now to expose it strictly as a built-in. Are you guys kind of in the same boat? I don't think anybody's looking at trying to generate these automatically.
We're in exactly the same boat.
Yeah, we only did.
Yeah, in GCC we're in the same boat. I think, to be totally open, Kimono, I think there are people within IBM who are looking into the possibility of you could generate some of these things automatically in the compilers. I have some skepticism about what you can do there because the true performance benefit comes from doing the blocking, which is a much more difficult thing for the compiler to figure out. You can recognize that you're doing matrix multiplication relatively simply. Can you figure out what the best blocking is for the target? Relatively
not
simply.
Bloody likely.
Yeah, seems so to me, I think there are people who are looking at it. I don't foresee GCC power backend jumping in that direction anytime soon.
Us either. We're trying to expose it for a team internally, and it's strictly a built-in so they can wired into the various libraries they want to use. So it probably looks exactly like what you guys are doing right now. And if somebody manages to figure out how to solve the bigger problem, great, we all benefit. But it sounds like we're roughly the same.
Okay. Yeah, sounds good. I think everybody's kind of spending a lot of time trying to figure out where to go here. I know that Intel's got their way of going and ARM's got their way of going. And I don't know, I think we're a long ways from the harmonic convergence, but I think there's a lot that we can share within the compilers on the things that can be done and agree to disagree on the things that can't be done. So
yeah.
I'm not even sure how many people actually roll their own matrix multiplies and rather just use an open blast or eigen type solution, which, you know, if we've gone in there already, or at least Raji's team has gone in there already and added all the support, then there's no real reason to have to roll your own.
Right.
Yeah.
If you use something that is automatically generated, it will be 30% slower, something like that. So you really do want to use optimized handwritten libraries, always.
That's what our team's doing.
That's what we're doing. The built-ins, they don't actually use registers in GCC. That's it's all faked out and stuff.
Florian had his hand up. I want to make sure that Florian got his question or answer in.
okay. I also see some things in the chat. So let's go
Florian
to Florian.
was there first, so let's
okay.
get Florian's.
Thank you. I didn't see the hand up. So go ahead, Florian, please.
So we are looking into switching long double to binary 128 in Fedora. And one thing that has come up in internal discussions is what to do about libg Fortran. And ideally, we would like to have a zoname bump at least, because the library API changes. But then the question came up, do we bump zoname only on LPC 64LE or on all targets? Is there another reason to do the zoname bump? And that's sort of currently blocking, or will soon block, Fedora experimentation in that area. Because we ideally want to do one transition with the right zoname.
It's also things like MPC and MPFR and GMP that have long double interfaces that you need to have a SO name bump too.
Yeah. You need to bump it everywhere at the same time, because there's only one name for everything, for all targets.
Well, maybe. So
it just seems like insanity to have different names that across the different architectures. I'm surprised that's even under consideration.
No
well, it's also switched by configuration. I mean, right now you can configure which of the 3 different long double formats to use.
Oh man!
And so, in theory, you should have a different zoname for each of the 3. Long double is 64-bit long double being IBM double double, and long double being IEEE 128.
So Florian, what's the reason? Why is it even being considered to have different names across the architectures?
Yeah, because other architectures probably don't like that.
Oh, it's just a convenience. So yeah. Okay, I get it.
Yeah, if you know, they don't have to change their surname because their types are not changing.
Yeah. Yikes.
It's going to break backward compatibility for all of them. So I mean, you're not going to be able to match up shared objects.
I'm glad this is not my problem. All right, I'll shut up now.
Yeah, I mean, I think Florian, unfortunately, I'm not sure that. I think that's going to be on you guys to decide what you want to do. I'm not sure that we have a valid opinion.
Yeah, but I mean, ideally, we would like to have libg Fortran compatibility across distributions. So we have to agree on the API and the zoname there. And libg Fortran seems to be slightly more central than, say, GMP or MPC or other libraries, which also may have long double interfaces in some areas, but which aren't used in practice that much.
Right,
I
but
don't know.
it's still like const poisoning, where that's how I found it originally. If I use the shared version of MPC and so forth, when I was building the tool chains for the different long double formats, it would say, the linker would say you're mixing objects between the long double types. And even though the compiler doesn't actually call anything with long double in the library, it's an all or none situation. You either have it, C and C++ work around this by just using the no attribute option on each of the modules that they're carefully hand building.
Exactly. Is there any other component in the ELF file format or that we can use to distinguish this or to prevent these two libraries from being
Yeah, we could.
intermixed?
There's attributes in the ELF libraries to say what the ABI is. So we could use that. Sure.
I think the issue is not the technical implementation, but
just deciding.
Yeah, making a decision. Have you guys reached out to Matthias, who does a lot of the Ubuntu stuff, and obviously Richie and the team at SUSE?
Not yet.
Those are probably the best places to start.
Yeah, I'm
I
sure
thought
most
it
will have
was
an
more like a PC upstream thing, but yeah, I don't know.
I'm putting my Fedora hat on for a minute and kind of trying to think as a distro guy. Yeah, we've got contacts at the distro level, so we ought to use them and try and figure out what's going to work best across the distros.
Yeah, that's probably a fallback if GCC doesn't want to take a position on that.
But all these things we'll find out when we actually start having a distro make the switch. And you have similar things like if you're on a distro that where the switch's default has been changed, does the automatic configuration of GCC mirror the system default, or does it default to long double IBM or IEEE?
Just when you think you're hitting the finish line, Bill, more stuff pops up.
Yeah, well, I mean we don't have any misconceptions that we're done. what we're done with is what we know about, and now comes the time when we find out more things that we don't know about. It's part of that.
Yeah, you're ready to start wider scale testing.
Right.
Thinking about the
We're
integration.
really hoping that we've caught everything, though.
Of course, of course.
But getting to the question about bfloat 16, I can't answer whether we want to do that. You're going to have the same sort of issues with bfloat 16, with just adding so names and things like that if you support a bfloat 16. And as I said, there are 4 different variants of the 16-bit coding point.
Exactly. What is float 16? Is that the IEEE precision format?
Oh, there may be more coming. Four is not enough to describe this problem yet.
so just to put my moderator hat on now, I'm gonna, if we're moving away from float 128, I think John Wakely's question was next. He has a question about the power darn instruction and whether standard random device should be using that to get a random number. And I think that the answer is yes.
But as I said, you do have to expect darn to fail. It can fail in a few corner cases.
No. It should use the built-in, no matter what.
Yeah, we have a built-in to use the darn instruction, and that should be used.
Yeah, and it actually works correctly now, the built-in.
Yeah. Yeah, so I don't think you have failure issues to be worried about there at this point.
So, Bill, I'm adding the questions to the shared notes like they did in the previous session. So you don't have to scroll through the chat. Next one is Joseph Myers, I think, if we are done with John's question.
Okay, very good. Thank you. Appreciate that. So yes, the next question is, are we planning to add Float 16 support to the PS ABIs and the GCC backend, such as recently has been added for x86-64 and is present for AH64 for a long time? Power is conversion instructions between binary 16 and wider floating point formats, though not yet direct arithmetic and binary 16, I think. That's correct, Joseph. That's the status of where things are. I can't speak to the future of processor development around Float 16. All I can point to is that we've got right now the only place that you'll find Float 16 is in the MMA unit and in those conversion
There's one other
instructions.
instruction to load them.
Yeah,
to
load them, right? It's a storage
to-
format only
yeah.
at the moment. If you're looking at scalar Float 16, it's only a storage format.
And Float 16 does not exist in any of the API.
Right, and we don't have any plans to announce anything further in that regard here, and I don't have plans around the ABI to add Float 16 support at this time.
Yeah, I mean, if we did, we have the whole issue like we have with IEEE 128, where you have to get glibc to do it, and then libstandard C++ and Fortran and so forth.
And of course, we've got BrainFloat 16 to worry about and all that. So it's
Well,
there's
that's
a lot
kind
of interesting mess.
Kind of easier even because it really is truncated single precision. So it's kind of easy to handle.
Yeah, I guess the short answer, Joseph, is not today. I don't have any plans I can share with you about that. Alexander Potapenko has written, how does call registers
No,
wiping?
that's from the previous talk.
Oh, that's the previous talk. Yes, you're right. That's it for the PowerPC BOF questions that are here at the moment. Okay, my apologies. I'm gonna go back to the chat. The unfortunate part about switching back and forth between the shared notes and the chat is the chat takes a long time to populate. What else? Other issues that people are interested in?
Looks like
chat.
Neil has another question.
Yeah, Peter has a question, but I don't see Bill anymore. If maybe just turn off his camera. So, oh, here Bill's coming back. Pedro asked about MMA performance, and I don't know if anybody.
We have Raji on.
Yeah.
I don't know if Raji can talk to that. She's the one who her team is the one that did all our MMA support in the open libraries.
Yeah, but Raji's only connected in listen mode. So.
Oh. Raji, is there a way you can go over to?
You can't switch over. I mean, she had need to disconnect and reconnect, but she can type in the chat and we can.
Oh yeah.
If she has any answer to that.
Yeah. Just connecting back up.
Hi, folks. Can you hear me now?
Yes.
Yes.
Okay. Apparently, trying to look at the chat really cratered my window, and I lost everything. So I apologize. Let's see. I think that I saw a question earlier.
Yeah,
in the chat.
Raji's coming back.
Yeah.
I mean, there's a question about MMA that Raji is reconnecting.
Yeah.
To.
And she's
Okay.
Reconnecting. There she is.
Hi, so to answer the MMA performance, so in OpenBlast we have internal benchmarks that are showing 4x performance, but then when it comes to the real world workload, we have a ResNet 50 model that uses PyTorch and then OpenBlast in the backend. We have used that and it is showing a very good performance compared to Power9. We have some recent publishes related to the performance numbers. I can point to that. And then to answer the next question, yes, TensorFlow also uses MME using Eigen. So Eigen is completely MME enabled for float and double, and it is all integrated with TensorFlow. So whoever uses latest TensorFlow version, they can benefit. They can get use of. They can use MME through Eigen. So it is all integrated, and it is. We are still working on some enabling low precision MME support there.
There is a question from Neil if there are no follow-ups on that.
Yeah, so the question about Boolean with PPC64LE, I think what you're talking about there, and this is a known issue with C++ and altivec.h, and there's a very simple solution to it. After you've included altivec.h, you just undef bool and everything is fine. That's kind of the way that your applications have to be built if you're taking advantage of altivec.h in C++. You can contact me offline with specific questions if you'd like about problems that you're having. But that's, there's nothing that's changing about that. The vector library altivec.h will continue to be the main way that you get at the vector built-ins.
Yeah, and there's the conceptual problem that an artifact bool is not the same thing as a C++ bool.
So Neil, if you're running into a problem like that and you see breakage where altivec is not, you're not opting into it, something that you're calling probably is. Some header that you're using probably is, because that's the only way that that's going to happen, is if somebody is including altivec.h at some point, and that, well, there's also some internals in terms of defining some of the keywords. But if you've got specific issues, you should open bug reports and we can take a look and try to help you with that. Okay, good, Neil. We'll try to connect with you and figure this out. Thanks. Yeah, John, thank you for just reading back. Thank you for taking a look at the darn thing. If you run into problems, please contact us. We'll make sure that we understand what the issue is you're running into. I think that it should be working as long as you're making use of underscore built-in underscore darn. That's the one you should be using. Great, thanks, John. Other folks?
Yes.
Yes.
Yeah. There's been a discussion on adding a new string function called memcomp-eq on the glibc list for comparisons that don't need ordering, because extracting the exact difference is costly especially for short inputs, and the compiler often doesn't know that the ordering doesn't matter and can turn memcomp into this new function. I don't know if you have seen that and have an opinion on that, or I think it would benefit our PC as well.
In GCC as a built-in.
Yeah, we've already got a memcomp equality that is an internal function in GCC. So I think we just have to map that. If you guys end up adding that API into glibc, I think we just transition our internal to have an external implementation. I think we're good.
But the compiler will optimize a normal memcomp to memcomp equal normally already.
Okay, then I will tell the submitter to move forward with the glibc implementation, if that sounds reasonable to you.
Yeah, I think so, unless Tulio wants to weigh in.
Yeah, I still have to check that and behind libc alpha.
Tulio gets a pass. He was on vacation last week, so he's still catching up on the mailing list. So give him a moment to look at it before you go forward, I guess, Florian. Thanks. All right, we have 9 minutes left. Still time to.
You can show some pretty pictures.
We could show pretty pictures. I've lost the ability to. Could I have the authority back? Thank you. There we go. There's a marketer picture.
Yeah.
That's Sager tells me this has been photoshopped, but that's the picture that people show for PowerPoint.
I hope it is, because that's not what
but here's a prettier picture.
Yeah, that was pretty.
So you talk about what you want to talk about, Sager, and tell me which pictures to go to.
Well, I think this is a very pretty picture, but I've got nothing to talk about. Right? It's just a big machine.
Yeah, this is the new high-end machine that was just announced last week. It's the Denali four socket guy here. So lots going on in there.
Can you send me one?
Carlos has his hand up. What's up, Carlos?
Yeah, so I think that that's an open question from Jeff, which is like developer boxes. Is there any conversation about that? It was a power BOF.
There is conversation about that, and we have people internally who are working on that. I will say that it's not going as timely as we would like it to go. There will be a GCC box going out to OSU, for example, and so on. So that's the immediate, the thing that we all want the most is to see that box out there, and there are plans for that. It's just not going as fast as we would like it to go. There are some of the interesting things about we partnered with Samsung, and they're so good that the chips are coming out with such high yields that getting cheap chips is hard.
Yeah.
And that's actually affecting some of this a little bit.
And for any development boxes or boxes for the compile farm or anything, it's not going to be a big box like this one.
And just to clarify, that is the IBM Power 10 E1080.
Yeah.
Which
That's correct.
Which is available from your IBM sales representative. Operators are standing by.
Yeah. Please pay our salaries.
So we got a new question from Christoph Milner.
Christoph.
You were mentioning single line patch in the backend that boosts the spec performance by more than 2%. Can we explain a bit more about it? Okay, so it's the promote mode macro. It would on 64-bit machines it would promote pretty much any parameter to 64-bit to be copied to a 64-bit pseudo and used as a 64-bit pseudo. But it turns out to be a lot faster if you just promote it to 32-bit pseudos. Everything has to be like 32-bit or 64-bit in PowerPC for normal operations on registers. But we always did 64-bit, and it turns out that 32-bit is a lot better.
Is we allow 32-bit operations, Sager said, and also just to expand on this, that it's also what the ABI specifies, and clarifying whether one is expanding function arguments, to the caller, returns from functions, and so we were being a little overly aggressive with that, and so that's what this.
this was when copying from a register that's used for register passing to an internal pseudo. Then we would make it 64-bit. And we don't anymore, and that's like more than 2%. Wow.
And I see Neil saying, you know, he wants Raptor to offer Power 10 systems. We'd all like to have more affordable Power 10 systems. Preaching to the choir, we would all love to have Power 10 systems on our desk too, but we don't have the control.
Yeah, that's above our pay grade for making those decisions. Yes, and if anybody's from AWS online, you know, we can help you contact the appropriate people in IBM, and happy to work with you to have power systems in AWS.
Actually, this raises an. Oh. Go ahead, Carlos. You had your hand up.
The Power 10 box going into OSU. Given that we've got a lot of people here that could answer some questions about, you know, the compute farm for the GNU tool chain, could we get a VM on that thing to then run the containerized tribots? Can we do that? Is that okay? Because I mean, like, I would like to put on a PPC64LE tribot effectively to cover patches coming in and make sure they build on at least a primary non-x86 architecture.
Oh yeah, I mean,
coverage.
So on the main compile farm systems, we do not really run VMs because they take up too much time, too much resources.
Well, it depends what you mean by compile farm. Because look, we have a cluster, the Power Dev cluster.
Okay,
we definitely can, you know, allocate another resource in that cluster. Now, I mean, Bill said that the Power 10 system is going to OSU. I don't know if that's a change. I didn't believe that was, you know, availability through OSU is different than going to be at OSU. So I think.
Oh yeah. So okay. This is just me, you know, my ignorance about physically how these things work. Yes, it may not be on-prem.
Yeah. So there's still how this is going to exactly work, where the Power 10 systems will be physically placed. I mean, because the Power 9 system, all the previous ones have physically been in the co-location center at OSU. So
I mean, if we have Power 9 today, I could try to deploy a container.
Exactly.
I could try to deploy, it can just be a container, but it's nicer if it's a VM with isolation. Yeah.
I mean, I know this is also a Power BOF. I mean, we're always at the end, but I mean, there's also but the reason I'm saying this is that also the Z systems at Marist, and we can help you create a long-term, I mean, I can help, I mean, Oli, of course, can as well, you know, long-term access to a virtual machine at Marist for Z tribot as well. So I mean, both of those are completely possible.
I mean, like, but in total transparency, the thing I want to raise here is there are operational security considerations for these machines getting totally busted, because the tribots, we're trying as hard to run code posted to a mailing list, right? And so as long as the people hosting these things are comfortable with that, then we have open code for how the container gets set up. The containers run without network connected. So, yeah.
Yeah, I'm afraid we're probably going to have to take further discussions of anything offline at this point, as I see we're running out of time, and I don't want to impinge on the.
Right. So Carlos and Jeff, please contact me. I'm sort of another hat I'm wearing is the main contact for both OSU and helping with the Marist Linux One community cloud. So.
Yeah, for sure. I mean, a community cloud would be interesting to get the containers up and running CI/CD and connect them up to Patchwork, so we get a second architecture on Tribot. Okay, I'll follow up with you, David, then, and I'll talk to DJ about it. Time is up.
Okay.
It's not. It's my time now.
We'll turn it back
okay,
to
well, let's just keep talking.
Thank you.
So yeah, Carlos didn't have anything useful to say. Okay, but look at that sexy image. I mean, you know, system port. I mean, this is very great. I mean, look at those yellow line, yellow wire.
So I did upload one slide. There's one ODP slide. I don't even know how you get the slides into this setup.
All right, so let's officially wrap up the PowerPC POF and move on to GLibC POF. So Carlos,
thank you,
off
everyone.
you. Thank you all. Take it away, Carlos.
Excellent. I don't know what to do with these slides.
If you press the little plus in the bottom left-hand corner, it should give you the option to upload a presentation or something like that. And if you drop it in, it will upload it, and then it should open it for you as well.
And doing the magic. All right, can everybody see that slide? Okay.
Yes.
Welcome. This is the GNU C Library BOF. We have a 45 minutes set aside to talk about open topics the community wants to discuss. I've preceded some of these topics here just to mention some of the things that have happened over the course of the last year. Obviously, we had glibc 234 come out just recently, August 1st. There was significant work there involving 64-bit time T, the work to merge a number of the libraries back into libcso.6. That included libpthread into libcso.6, and a bunch of other features. We are currently developing the upcoming glibc 235 release, which will release February 1st, 2022. So development's open right now, and I wanted to give time for the community to talk about any open topics. Some of the open topics that I think are interesting is perhaps asking if there's any feedback. We've been doing 10 months of patch queue review, which is to say every Monday there's open discussion on IRC and via a audio and video chat framework in which we discuss the open queue of patches as they are in patchwork. And I also want to say, you know, I'm very interested in how do we make it easier to gain consensus for basically accepting patches that have been reviewed and committing them. And that's kind of where my priorities end in terms of thinking about, you know, things we can talk about for the BOF. But let's turn it over to open topics. Does anybody have any open topics we want to talk about for glibc right now? And I've got the chat open so I can look at that. Komathi, are you taking notes for us?
I can, but
You do not need to. Yeah, I heard you earlier saying something, and I wasn't sure if that was if you're.
I was just trying to get the questions because questions keep scrolling. I was moving the questions to the shared notes, which I will do for the session as well.
Sure. I'm going to watch the live chat, and I'm going to take notes on the side, and then I will post any notes from the glibc BOF right now to libc alpha when we're done the BOF, in case anyone wants to raise any question. Yeah, Michael, anything you want to ask? So I know we just had the IBM BOF, and there's still IBM people in the room. Are we ready for the PPC64LE long double change and downstream?
I think we had the issues pointed out about libg Fortran that needs to be discussed. But otherwise, things have been moving well on other upstream communities. So despite that, yeah, I think it looks okay.
Okay, that sounds good. I'm trying to remember if there were any other power. I mean, there are some other power features, but I don't know if there's anything else that needs as much hand-holding as the ABI transition. Yeah, I think that's pretty straight. Bill, anything you want to say?
Yeah, if I have my mic down, you can hear me. I was just pointing out that John had something in the chat about there being a libstandard C++ bug he still needs to look at regarding the long double change.
Okay, so I'll make a note. Yeah, I see. So Jonathan says open libstandard C++ bug needs fixing. Yeah, it's just something. Yeah, but I'd say, Jonathan, that we have to make there's kind of this decision that happens as the whole GNU tool chain, in that we prepare for the change, and then downstream the distros have to decide that that's a transition that they want to take. I think in this case, the areas where I work on would be in Fedora, and looking at that transition as a system-wide change. But again, not necessarily a topic for glibc BOF, but I was curious if all the glibc pieces were in place, and I think we largely are. And I've just taken notes on libg Fortran and libstandard C++ being places. I can talk a little bit about, yeah. So I guess I want to garner some. I do want to garner some feedback. We've been doing weekly patch reviews, and I'm curious for honest feedback from anybody in the community who's been attending those meetings. Have they been valuable? Can we structure them differently? Have they been working to ensure that senior reviewers, for example, have their eye on things that community members think are important? I know, let me go down the list. I wonder if Lukasz is here for the 64-bit time T patches. I think he attended several meetings to ensure, to kind of drive visibility for the patches he was working on. Yeah, Florian, any feedback on that?
I think over the last month or two, the focus has shifted from general discussion towards general discussion, and we don't really make much progress on the patch list as much as we used to. So yeah, I mean, I think it's useful. It's also useful for like feeling connected to the community, I suppose. But yeah, it's not really a patch queue review right now.
Yeah, more than general discussions, we tend to do like a deep dive on specific issues, and those issues tend to be owned by people who are on the call. So there's definitely that skew, and because of that, we kind of tend to focus on issues that like 5 or 6 people who attended the call have raised, and the patch list kind of doesn't get as much visibility as it should.
Yeah, so as basically as like chair for the patch review, I can give preference to effectively like walking the queue first and then asking people for any critical issues they want to raise, and or refocusing that meeting. So I'm taking notes, which is, I think it's valuable and we should refocus on the queue. Yeah.
And probably find ways to attract more people on the call. I don't know how calls are not always the most favorite thing of most people. So I'm not sure if more calls or anything of that sort would actually solve that problem.
Yeah, I don't think more calls would solve the problem. It's one of those things like, how do we focus review energy, potentially catching people who'd submitted new patches and that those new patches need review. I find that for me, the weekly queue helps me, for example, pick things that I think team members would be able to review, and then gently guide people to say, hey, look, these patches are something you could review. It's within a subsystem that you're familiar with, and we need that thing to move forward. And I catch submissions from like new people submitting things that I say, oh yeah, that's definitely someone from a drive-by contributor. We want to make the experience for that drive-by contributor positive, so let's pick that and put someone on it. I agree with you. We lost a little bit of focus. We probably need to refocus on the queue for review, and refocus making sure that we're reviewing the queue, and if anybody wants to hand something out, we hand it out. I've been tracking the queue data. I didn't prepare a graph for it, but it was interesting to see, like, when we focus on that queue definitely goes down. When we defocus on the queue goes back up again, because I know when we focused on, as we approached the 234 release, we got the patch queue down significantly under like 250 or something, and now it's back up because patches are slower to review. You know, I think we're a little defocused in the early development as we go, and we catch up on other tasks that we haven't done as we focused on the release. So yeah, so retrospective on 10 months, I feel like it's been a success, and that I've made a note about refocusing on the queue for review.
There's another question on the list, Carlos.
Sure, double checking that. So Lazy Parser has handed over this account to Masqueray. Hello, Fangray Song. How are you doing? Will glibc be happy with Clang buildability? The most important patch is to removal of C-nested functions. This patch has been up for several weeks now. So I can answer for myself. I think it is perfectly okay to be able to build with other glibc with other compilers. And in fact, I am strongly against nested C functions because I don't think they improve readability, and it's difficult to use them, and they have debug consequences. So if we need to review a patch, then we need to review a patch. And I think that's basically probably a failure of the Monday patch review, and that we need to refocus on the queue. Let me find that patch and see. And Joseph Meyer's asking about Bugzilla triage, and I'll get to that question in a second. Patchwork. glibc.
So I looked at this patch actually.
Yeah.
And the trouble I see that I wasn't sure is if it's possible to use static variables for the bootstrap allocation. The nested functions, as far as I can tell, the nested functions in this context aren't just convenience, but are also required to avoid a relocation dependency for the bootstrap allocation. So you actually have to put the global state into a struct and pass it down by a pointer. I could only test this on one target that requires bootstrap allocation of the dynamic loader itself, and that seemed to work, but I don't really know what that means in general, or if the testing was good enough.
Yeah, I think the issues you're raising, Florian, are real issues, but hell if I know how to test that thoroughly. I know I looked at this code several years ago, and yes, nested functions are a requirement. You might be able to get away with using inlines instead of nested, but gosh, this code is painfully hard. And so I'd love to see us get away from it. The question is how to do so in a safe way.
But I mean, like, we can restructure that code. There's so much data that get passed down in those functions that it probably should be a closure that has all the data in it that you need. And then it makes it way simpler to audit and way simpler to review. Joseph is making great comments here on the list, which is, regarding Clang buildability, each separate logical change should be sent separately. And so to answer Fengri's question, absolutely, we would be happy with Clang buildability. You know, where it makes sense. I think we've had other discussions, for example, like the LLD Pi pick discussions, and largely what it comes down to is simply a technical discussion, making sure that the technical choices we're making for the library and the project make sense when we're targeting some of these features.
It's probably a bad idea to avoid GNU extensions. Just because they are GNU extension. If using the extension actually improves performance, even if it's just 1 promille or whatever, then it improves performance, and we should not throw it away because some people want to build with CLAN.
Correct. And so those are technical considerations. But for example, nested functions don't give great debug experience when you're debugging that code. So there's already a maintenance impact for these things. So like already they cause problems. Now, the technical consideration, which is Florian says, is what do you do with the bootstrap relocations? In that case, I think it needs a rewrite to use a closure. And then when you rewrite with a closure, the code gets even cleaner. It gets simpler. Yeah.
But it already is written with a closure. That's what nested functions are.
Well, I think Carlos is saying a more explicit closure build.
Okay.
Yeah.
As opposed to kind of this, we're faking a closure with nested functions. That's what we're doing.
Sure. And now you want to fake it explicitly. Okay.
Well, we don't fake it explicitly. I mean, like in glibc, there are areas where we pass a closure, basically a structure to a function with its data. But yeah, it's a faked closure, sure, if you want to call that a faked closure.
Yeah. Same purpose. So.
Yeah.
I mean, if everything else fails, we can also look at the relocations, I guess, and do the bootstrap relocations in uncrafted assembler code or something like that. But
yeah.
I mean, the issue is even if it links today with build many glibcs, I don't know if it runs on the targets that require bootstrap allocation, and I don't really know how to test that.
Well, and it might work today, and it may not work tomorrow.
Yeah.
We need to really understand the state that we're passing around and how to make sure we avoid the relocation issues. And I think if we design it around those two questions, we'll get to something that works and we can reason about it.
But I also feel like we're in a fail-safe mode here. Like, honestly, if this blows up, we blow up in early bootstrap and it's going to crash. And then the week that we integrate this thing into a downstream. So I'll give an example. In Fedora, we do weekly syncs of glibc development into Rawhide to keep it rolling forward. Like the second we see a toolchain change that brings this change in, it'll blow up, or we'll notice it. So it to some degree, there's a fail-safe aspect of it if we end up with relocations that are bad. I feel like we're going to see this if we break this. But that's just my feeling, because every time we've done something like this, we have seen it when it breaks right away.
If you actually do testing on all architectures that you need to test on.
Yeah, well, we test on PPC64LE, we test on x86, we test on Z, we test on AR64 and 32-bit ARM. We don't.
Yeah.
Which target?
Alpha.
I actually have alpha in my tester, so if you put it into the tree, my tester will bootstrap GCC and build glibc and use it.
Yeah. I was just pointing out hardware that glibc still supports and that no one owns. So
yeah. Alpha, HPPA. Well, people still own HPPAs, but nobody cares.
Yeah, I don't. Yeah.
So anyway, my point being is I have a tester that would give us a heads up on some of these esoteric targets. And so if when we get to that point where we want to move forward, we have ways of doing some deeper testing. I just want to make sure that when it's designed so that we have confidence that it's correct, as opposed to it seems to work today, but we don't know where it's going to be in a month.
Yeah.
So that's probably what should improve with the glibc loader, whatever you call it. That you do not need to test it on so many targets to have confidence that it works. So it's okay. So there are some things you need for the bootstrap, right? But but that's maybe a handful of things, right? You don't need tens of things like you have now. So if that is improved, then it's suddenly a lot better testable and provable in general.
Yeah. HJ, I saw you wanted to make a comment there. I think.
Yeah, I agree with. I have a echo here. Most people said here. I think I removed the nested function supported should be broken into a multiple smaller patches. So instead of doing a one big one, that's many things can go wrong, especially for those targets they are not well tested.
Mm-hmm. Yeah, I'm gonna. Okay, so I've taken some notes there, and I actually think the avoid nested functions, avoid nested. I don't know why it doesn't show up in Patchwork. Anyway, I'll have to figure out that later, why that patch that's linked there doesn't show up in Patchwork, or at least I can't find it quickly. Joseph did ask a question, and I want to get to Joseph's question, which was, could we do Bugzilla triage better, especially making sure bugs that have been fixed are closed? This seems like a similar backlog issue to patch review. So here's my answer to Joseph. It is absolutely a similar task to patch review doing Bugzilla triage. But last Cauldron, when we got together in this BOF, I asked the general question, should we do bug triage or should we do patch review? And there was more support for driving a process of patch queue review because of the benefits it brought. We should absolutely try to do a Bugzilla queue review, and I applaud Andrew Pinsky in GCC for the work that he does cleaning up the GCC Bugzilla, and it's simply time in from individual contributors. Joseph, I think that the contributors do try to tag a fix with a bug number and then close that when it gets fixed when we can do that. I don't know how to make this process easier other than it costs resources. It just costs people's time to review the Bugzilla, and we do and could develop a community practice of doing some kind of weekly review where we go and we check what came in and we try to do a quick triage of what came in, and we try to find people to help with that triage. So I do think it's a similar process to the queue review. We just haven't started that process yet. So maybe, does that answer your question?
What we do in GCC is when you do a commit, which matters for some PR, you mention that in the commit message, which in the change log, as I had before the change log, and it then automatically ends up in Bugzilla. So everyone who cares about that bug will get the email about it, and then you can close it, and that usually works.
Yeah, there is similar process in DDC. The problem is the hook does not look at the commit subject. So even if you put the Bugzilla number in the commit subject, it won't show up in the Bugzilla.
We broke the hook, I think is what it is. So the glibc commits and that hook need to get cleaned up. So yeah, that is a place where Seger, it is absolutely a place where we have to do a little bit of community improvement in the infrastructure. We used to have the hook. When we switched to the new 8-core hooks, we got the 8-core hooks improvement, but then we busted the commit hooks getting set up properly. Yeah.
Yeah, the GCC ones were broken for a while as well.
I think, yeah, something changed in the 8-core hooks. It used to work, we tested it, and then it started to break, and now it no longer looks at the first line of the commit for some reason.
I'm gonna put some stars beside this as something that we need to come back and fix, because it does make it harder to close bugs. If you see a bug and it's got a commit that was blatantly posted, then someone can immediately have the attention to go and mark it closed as in the current ones. So I think I've got refocus on the patch queue for review is something that I can help drive, and the other one is fixing the hooks.
Within the GCC arena, I find I keep the bug open until I do all the backports, which are usually a few weeks after the main commit, rather than closing the bug immediately. That way, when I port it back to GCC 11 and possibly GCC 10 and so forth.
Mm-hmm. Yeah, there could be a little process gap there if someone wants the bug. We have some keyword tags that we do use to say I want this bug in this branch, but we don't effectively use it. Mostly, I would say, Michael, because the downstream distributions backport actively to the release branches just based on their own needs. And so we often don't even have bugs associated with those, and we engage the downstream distros in helping us decide what needs to get backported to the release branches, and we empower them to do the backports to the release branches.
Might suggest that you put a comment in the bug when you've got it upstream, and you're expecting to move it downstream, so that people who aren't as familiar with the process but are very interested in a particular bug will know that, oh, my fix is coming.
Yeah, and I think that fixing the hooks should fix this, because what should happen is the distro maintainer does the backport, posts it to libc stable, which is the discussion list for stable backports. But as soon as they commit, my expectation is that the release branches are actively monitored by the hook, and therefore the bug should get an update saying this release branch got updated with the fix backport that you just had. So my feeling is that, and correct me if I'm wrong, Patrick, if you think this doesn't work, but if we fix the ADA core hooks to report again for the release branches and for the active development branch, when a distro maintainer does the backport to the release branch, and it will generate that Bugzilla comment saying fixed on release 234, fixed on release 233, so that you're getting the notifications if you're CC'd to that bug. Even if it's closed, you'll still get the emails.
Certainly, automation is an excellent thing. I just was the primary bug report before you're ready to close it, when you've done the very first commit at the upstream.
Mm-hmm.
Is there a mechanism for making something happen, or should we just remember to make our change in the bug report?
Oh, you mean wanting to make a change in the other downstreams? There is
no.
Oh.
When the upstream change commit happens, the reason I'm mentioning this is I did a fix for complex divide in GCC, and I forgot to update the bug report. A couple of months later, I went back to look at the bug report because it occurred to me I hadn't put anything there. And somebody else had said, hey, I'm going to look at this, when we already had a fix in place. So they wasted some effort because I was slack in updating the bug report at the very first commit.
Mm-hmm.
And there was no automated activity in GCC to say, a patch relating to this has been done.
So as far as Seger's saying, I think, though, the commit hooks for GCC should have posted a comment if the commit had a bug reference in it.
I think that bug reference was missing because the complex divide was not really triggered or driven by that particular bug reference. The bug reference was a very minor issue relative to what the commit dealt with.
The GCC hooks only do it if there's a bug reference in a specific place before the changelog. And you don't even have a changelog in your commit message anymore in glibc, right?
We don't, but we look for bug numbers, bug XXX on the subject line.
Cool.
Oh, we used to.
Until it broke.
Yeah. What I do is, if I see a bug that has been fixed, then I usually do manually what a typical commit hook would do, like post the commit details to the bug and then close the bug with. And Joseph pointed out we need to close the bugs because of the news file generation logic. So actually fixed bugs have to be resolved, fixed, otherwise they don't get listed in the release notes. So yeah, we would have to mark backport candidates in other ways.
I agree. I think backport candidates are probably a separate discussion, either a separate bug with the appropriate backport tags indicating which branches you want it on. But like I said today, the initial design of the process was to be as lightweight as possible, which is the bug gets done, it gets fixed. Once the bug is fixed on the development branch, it's going to come out in the next release, and if anybody wants it, then we are empowering them to engage on like libc stable mailing list and just do the backports, because things that don't change ABI should be backportable to the release branches.
And we should
In
go
GCC, we have fields in every bug that says known to work, known to fail. So you at least know when a bug is filed already, right? Or when it has existed for a day or whatever. You know what releases it applies to. So when a patch eventually shows up, you know whether you could backport it and everything.
Florian, did you want to raise another topic?
I saw a question from Jeff on explicit loader invocations. I could answer that.
Yeah, please
That'd
go
be
ahead.
awesome. Please do.
So we actually saw a lot of these. So I fondly remember, I think it was a RHEL 6 kernel bug where you actually could had the S break area was like 128 megabytes away from the stack bottom, or top of stack. So depending on what the program does, you could actually consume so much heap that once a deep recursion started, you crash because the stack can't be extended anymore. And this stuff happens all the time. Usually those are kernel bugs because the ASLR is not set up correctly in the kernel.
Yep.
And yeah, this is just, I think it's mainly a matter of tuning the kernel ASLR defaults so that this doesn't really impact applications that much. And the layout changes, that's true. But in the future, I actually expect more use of the explicit loader invocation because, as you might have seen, we have added more options to the loader, more capabilities. And in some ways, it's more predictable than using environment variables because what you do to the process doesn't automatically get applied to sub-processes that process creates. So, yeah.
Yeah, so it sounds like the position would be that the changes in memory layout really shouldn't impact things if you've got ASLR and you have enough space in your address space that you can keep things at a reasonable location, which is that's a fair place to be. I think part of what got us looking at this is, and I don't have the details on the specific piece of it, but we ran into a case where Erno was, we were trying to allocate, we couldn't allocate, Erno got set, we went to a different arena, got a valid allocation, but nobody ever cleared Erno. And so people were surprised by that, and that's what got us looking at it. But if the position is, if you're going to run something via ld.so, you should expect a degree of change in your memory layout, and you have to deal with it. And that's a reasonable expectation, I think.
Yeah, obviously the kernel should lay out things so that you have a sufficiently large stack and S break.
Mm-hmm.
And
yeah, and that maybe it would have gone, what went wrong for us, I'm not sure.
Yeah. And there are two cases you need to deal with, actually. That's the randomized address space turned on, and the other setting is randomized address space turned off. And the tricky part is, I mean, we have builders that disable randomization for increased reproducibility. That kind of tends to trigger different kinds of bugs. And of course, if you run stuff on the GDB, you also get randomization disabled by default. And the kernel has been known to generate fairly bad layouts with randomization disabled on some.
Yeah, and I think we might be running with randomization disabled by default, because we know it works, and so we turned it off just to make the reproducibility problem easier to tackle right now. So that may be related. So I'll check into that. That is a good piece of insight.
Yeah, and then there's the issue of performance differences.
Yep.
If your hardware has certain cache behavior or something like that.
Yep.
Yeah, but I expect more users of LDSO, and I actually want to install it into user bin eventually. Okay. So this is really something that should work out of the box in a reasonable way.
Thank you, Florian.
Okay, so that answered Jeff's question, and I took a note on changes in memory layout should not impact things due to ASLR. Yeah, I mean, we have seen bugs where if the kernel invokes LDSO first, then it does some layouts that don't work because there's like not enough memory, but those shouldn't happen in modern kernels. I'm trying to go through here. Wei Wu was talking about issues with resolve map. Joseph again talking about fixed and white spaces and what to trigger bug updates on, and I think that's just related again back to our Ada core packages. And for those of you that don't know, yeah, we have CI/CD running in Patchwork for glibc, running a patch application tribot and a i386 regression tribot, which does catch stuff, and I think we can improve that, and I'm going to be adding to the tribots that run so we get some more coverage. Any other questions from the audience or developers? I'm going to see if there's anything else. Florian, anything you want to raise? I see your mic.
Yeah, if no one else has anything, what about the main list and the from rewriting? Can we get rid of that? This is one of the most annoying issues, I guess, that I deal with.
The from rewriting is annoying because Patchwork then sometimes mangles the from and drops the patches out of people's queues in the Patchwork patch tracking.
Yeah, and git am also doesn't work, and that's also very annoying.
Yeah.
Yeah, I put in a commit hook that disallows pushing these patches to the repository, but
so this is it's a good question. I don't have an answer. So I assist as a volunteer with overseers for issues related to mailing lists and other parts. So, I mean, sourceware.org, we should be able to do this. So I think did we write up a formal request to overseers to say, can we look into this? Is this something we can fix? I don't know the status of that. So if I'd say anything, it's a formal request for a change in configuration via overseers. Mark Vila.
The issue there is that we would have to stop stripping HTML attachments posted to the mailing list.
Yes, the rule is don't change anything, and if you don't change anything, then you don't need to worry about deacon breaking and so on, and you don't need to rewrite from headers at all. Konstantin Rebetsev has done using MLMMJ with the kernel list, in which he talks about this. It's worth looking at if you haven't already.
Yeah. If I'm being honest, I think we shouldn't be changing anything. And in this modern day and age, we'll have to find a way to deal with mail to the list and avoid the from rewriting, which I also dislike.
Yeah, so
the obvious alternative to stripping HTML is simply refusing emails that have HTML in it.
Yep.
But that's not really friendly to new
Yes,
contributors.
that is also troublesome because either you drop the email completely and then people end up oblivious to the fact that you've rejected it, or you send back an SMTP rejection code, which often gets ignored, or you bounce it, in which case you're suddenly a source of spray, and you should never do that. But there are no good answers here.
Well, no, I think the good answer is we just start allowing all email, and and that's it, because it's an open mailing list and people should be able to post in ways that they want. So not passing judgment on exactly how people are going to send email to our list, but passing technical judgment on what we expect from the quality of their contributions.
Exactly. If people can't sanitize HTML email into something they can read, I did think they probably shouldn't be on any technical mailing lists or any mailing lists at all in the modern world.
The only open question that would remain there is, like, does this mean we get a bunch of spam to the list? And I think that simply has to get handled by a spam filter. So Florian, do we have a way forward then? I think is it a request to change nothing and allow HTML email to overseers?
Yeah, I mean, the goal is to be able to stay compatible with DKIM and not to do from rewriting, I guess.
Yeah, it is.
And also don't wrap. I saw some mailing lists do like wrapping the original message as an attachment. And yeah, I think it boils down that we transition from one self-supported mailing list manager to another self-supported mailing list manager. In the sense that the upstream is basically dormant, and maybe our mailman version that comes from CentOS 8 doesn't have all the newer features patched into it.
We don't know that yet, right? So that would be supposition. In this case, what we really have to do is stop the rewriting and allow HTML mail, and then if that lets us move forward, then we can move forward with that, as long as we can keep delivering that and accepting it. Yeah, Mark, I was going to ask, I see Mark is here, but Mark, because I know you have some experience with this and we've talked about this before, do you have any feedback that you want to give, Mark?
No, not really, except that this, I'm not the person doing the mailing lists, and you really have to get buy-in from Frank and Christoph.
Okay.
I see there's a question, can B4 be used for glibc patches posted on libc alpha? If you can point B4 to publicinbox.org, I think you should be able to use it because libc alpha is on publicinbox.org. And I hope that answers the question. I also like B4 more than Patchwork because Patchwork requires an access token even for read-only access. So if I have a lab machine that I don't trust fully and want to apply a patch there, then I can't use Patchwork.
You can. We just make an account for the lab machine and we give it its access token, and the lab machine gets a restricted account rather than your privileged account that allows you to edit everything because you're a senior maintainer. Would that work?
Yeah, but it's kind of pointless, right? I mean, the data should be read-only and available without authentication. I mean,
I don't disagree with you. I don't disagree. But the way that systems get built is that it requires that access token. So we can submit something upstream and say, would there be a way? Like, I mean, I was just talking yesterday to some of the Patchwork maintainers because I raised some Patchwork issues on Twitter surrounding conversations here. and yeah, and they are open, and they're curious what our use cases are, and they're curious where we've got problems. So I think the Patchwork maintainers are open to us filing a request and saying, hey, could we get something without an access token for read-only list access? So I don't think it's a dead end.
Maybe it's also just a peculiar configuration on our end.
Yeah, I haven't tried, but I believe that just about every Patchwork client starts off with needing an access token in order to gain access to the APIs, and you protect yourself potentially from like unauthenticated access. Like it would only be DDoS protection you would have, right, if someone had unauthenticated access. So yeah, I don't know what happens there. So I hope we answered the question. Can you use B4 with libc alpha? Yes, if you can point B4 at libc alpha on public inbox. I believe, Florian, correct me if I'm wrong, it's like the non-official upstream public inbox is archiving libc alpha, so you can point it at that list.
I thought it was there, but I'm not sure really. But
it is. I even looked at it yesterday. I'll see if I can dump it into the chat. It's not lorekernel.org. It's the other public inbox archive. I think it's unofficial mirror of libc alpha and publicinbox.org. Yeah, you got it.
Oh.
Yeah.
Yeah. Okay.
You beat me to the paste. Yeah. Yeah. No. I mean, like, and also public inbox is spectacular for the speed of the search, the speed of the static page displays, and going through libc alpha and public inbox is really, really, really nice. I think it's another infrastructure piece we could talk about, but. So we're 2 minutes past the time for the BOF, and I want to be conscious of people's time. Let's say it's like, why didn't I know about that? Yeah, I want to be conscious of people's time and thank everybody for coming and asking their questions. I think we got through a handful of questions, which were, are we ready for the PP64LE long double change in downstream? I think the answer is yes, except a bug. I said patch review retrospective on 10 months of patch queue review was refocus on the queue for review. I think that should help. The next question, which is Feng-Ri Song was saying, will glibc be happy with Clang buildability? The answer has been yes. Joseph's suggestion is patches should be split into logical changes. Feng-Ri, I almost got to responding to your email. I'll respond to your email after this, and I think we request that the patch that we have for 2.7.2.2.0 be split into a smaller series of patches to make them easier to review. And we need to solve this answer about bootstrap relocations. Joseph asked, could we do better in Bugzilla triage? And the answer is yes, but I think we can do it by starting by fixing the broken hooks to make it easier to close bugs, and from there begin a more organized, maybe weekly process of bug review. Jeff asked about explicit loader invocations and results in different memory layout, and we said, yeah, you're going to get different memory layout because the kernel's going to load LDSO first, and then it's going to map things in, but hopefully with ASLR it works. And Florian asked about mailing list and from rewriting, which is problematic with both GitAM and Patchwork. And I think the action item there is to, as Mark says, talk to Frank and Christopher Failer and see if we can get buy-in about no rewriting, all HTML allowed. And that's it. Thanks everybody for attending the glibc BOF. See you guys throughout the rest of the week. And someone tell me if I'm wrong. We're supposed to end at 1:45, I believe, and there's no one after this.
That's correct. So we are wrapping up after this session. So thank you, everyone. Thank you, Carlos, for hosting, and thank you, everyone, for your participation.
Do we need to thank our sponsors before we close? Is that?
I believe that's our lead's job.
Okay.
Yeah, so again, thanks very much for participating with the third day of the Linux Plumbers Conference, GNU Tools Track. We thank the sponsors of the Linux Plumbers Conference this year, starting with Facebook as the diamond sponsor. Thanks very much for its incredible support. IBM Platinum level sponsor. Great work from them. Gold sponsors are ARM and Microsoft. The silver sponsors this year are Amazon AWS, Netflix, and Red Hat. And we appreciate Collabora for the sponsoring the speaker gifts, and VMware for providing t-shirts, sponsoring the t-shirts this year, and all the conference services provided by the Linux Foundation, including the great work by the program committee of the Linux Plumbers Conference, David Woodhouse, James Bottomley, Christian Bronner, Jonathan Corbett, Guy Lunardi, Steve Rosette, Kate Stewart, and Elena Zanoni. And thank you very much also again to Embacosm, especially Jeremy and Sarah, for the great work in helping to coordinate the GNU Tools Track this year and the infrastructure and administration. So thanks everybody, and see you tomorrow.
you.